Wilhelm Röntgen and the discovery of X-rays. All right, let's talk about one of those discoveries that literally lets doctors look inside your body without cutting you open. We're talking about X-rays, and the man behind them was a German physicist named Wilhelm Röntgen. Now, Wilhelm wasn't some crazy eccentric like Nikola Tesla, but he was definitely the kind of guy who would spend hours in his lab tinkering with things most people wouldn't even want in their garage. It was the late 1800s, and scientists were obsessed with electricity, weird glowing tubes, and strange invisible forces that no one really understood yet. Think of it like the Wild West of physics. People were experimenting with sparks and beams and light, and half the time they didn't even know what they were seeing. So here's where it gets interesting. In 1895, Röntgen was working with a piece of equipment called a cathode ray tube. Don't worry, you don't need to know the physics behind it. Just imagine a glass tube that glows when you run electricity through it. Scientists used these tubes to study invisible rays, and most of the time it was just boring lab stuff. But Röntgen noticed something strange. When he turned on the tube, even though it was completely covered up so no light could escape, a fluorescent screen across the room started to glow. That shouldn't have happened. No light should have gotten out. Yet somehow something invisible was shooting out of the tube and making the screen glow. Now here's the part that sounds like it belongs in a science fiction movie. Röntgen started playing around with this invisible force, and he noticed that if he put objects between the tube and the screen, the shadow would appear, but not the kind of shadow you and I are used to. Thicker objects blocked more of the rays, while thinner things let them pass through. He eventually held up his hand, and what showed up on the glowing screen wasn't just the outline of his hand, it was the bones inside. Imagine seeing your skeleton for the first time, glowing and ghostly like something out of a horror story. That moment was history. Röntgen had just discovered what he would call X-rays because he didn't know exactly what they were. The X stood for unknown. And of course, once he realized what he was looking at, he did the most human thing possible. He called his wife into the lab to test it out. He asked her to place her hand in front of the tube while he captured the image on a photographic plate. The result? The world's very first X-ray photograph. Her hand bones with her wedding ring glowing bright. Legend has it that when she saw the picture, she was horrified and exclaimed, "I have seen my death!" Which, to be fair, is a reasonable reaction if your husband suddenly shows you a glowing skeleton hand. Now here's the fun twist. Röntgen wasn't trying to discover X-rays. He was just experimenting with cathode rays like many other scientists of his day. The difference was that he paid attention to something most people would have ignored. That glowing screen could have been brushed off as a mistake, a fluke, or even a broken piece of equipment. But instead, he leaned in and asked, "Wait a second, what's happening here?" That curiosity is what made all the difference. Within weeks of his discovery, Röntgen's work went public, and the world went absolutely crazy for it. Newspapers everywhere called it a miracle. People were lining up to get their bones photographed. Imagine how mind-blowing that was in the 1800s. Suddenly, you could see inside the human body without surgery. It was revolutionary for medicine. Broken bones, bullets, swallowed objects, you name it, doctors could now detect it. Of course, as with most new technologies, people also found weird uses for it. Shoe stores in the early 1900s had X-ray machines so you could see how your feet fit in the pair of shoes. That sounds cool until you realize they had no idea about radiation safety back then. Customers and employees were casually getting blasted with X-rays for years just to try on sneakers. Not the smartest idea, but hey, it was the early days. And here's a wild fact. Röntgen never tried to patent his discovery. He believed X-rays belonged to the world, not to him. and that everyone should have access to them. Because of that decision, the technology spread like wildfire. Within just a year, X-rays were being used at hospitals worldwide. Think about that. Most discoveries take decades to become mainstream. But X-rays? Practically overnight, they become one of the most important tools in medicine. For his work, Röntgen was awarded the very first Nobel Prize in Physics in 1901. And get this, he donated the entire prize money to his university. He didn't care about fame or fortune, he cared about science. In fact, he was so modest that when he died, he asked that all his scientific papers be destroyed. He didn't want people glorifying him, only the discovery. Now, let's pause and reflect here. Think about how often we go to the doctor or the dentist and get an X-ray. It feels so routine now, like no big deal. But before Röntgen, if you broke a bone or swallowed something sharp, the only way doctors could figure out what was wrong was by cutting you open or guessing. His discovery turned the human body into a mystery box that doctors could finally examine without butchery. That's an insane leap forward. And all of it happened because one man noticed a glowing screen in his lab and thought, that's weird. So the next time you're sitting in the dentist's chair with that heavy lead apron on, waiting for that quick click of the X-ray machine, remember Wilhelm Röntgen. He wasn't trying to invent the future, he just stumbled onto it because he paid attention. And in doing so, he gave us a way to see the hidden skeleton inside us all, something humans had only ever imagined before. Pretty spooky, pretty amazing, and all thanks to one guy in a lab who didn't ignore the strange glow in the dark.
Percy Spencer and the microwave oven. Okay, let's be honest. If you're like most people, your microwave probably gets more action than your stove. Midnight snacks, reheating pizza, making popcorn, it's the lazy chef's best friend. But here's the part you probably didn't know. The microwave oven wasn't invented by some fancy food scientist or chef. Nope. It was discovered completely by accident by a self-taught engineer named Percy Spencer. And it all started with a melted candy bar in his pocket. So who was Percy Spencer? Well, he wasn't born into money, and he didn't have a long list of degrees like a lot of inventors. In fact, he only had about a fifth-grade education. He grew up poor in rural Maine in the early 1900s, lost his dad when he was a toddler, and his mom couldn't take care of him. He was basically raised by relatives. By the time he was a teenager, he was working in a paper mill just to help support himself. Not exactly the background you'd expect for someone who would one day change how billions of people cook their food. But Percy was curious. That was his secret weapon. One day, he heard about a local paper mill that was going to start using electricity, which was still a pretty new thing in rural areas. Most people didn't care, but Percy thought, I should learn how this works. So, without any formal training, he taught himself everything he could about electricity. By the time he was in his early 20s, he joined the Navy, and that's where his real education began. In the Navy, Percy worked with radio technology, things like radar, transmitters, and electronic systems. Remember, this was during the early 20th century, right around the time when radio communication was becoming critical for ships and eventually for World War II. Percy had a natural talent for tinkering with machines, and he became an expert in radar technology. Later, he got a job at a company called Raytheon, which was heavily involved in developing radar systems for the military. And this is where the microwave story kicks in. One day, in 1945, while Percy was working on a radar system that used something called a magnetron, basically a device that generates microwaves, he noticed something odd. He had a chocolate bar in his pocket, and while he was working near the magnetron, the chocolate bar melted. At first, he thought, weird. But instead of just shrugging it off, he decided to investigate. So he started running experiments. First, he placed some popcorn kernels near the magnetron. Sure enough, they started popping like fireworks. Then he put an egg in front of it. That egg ended up exploding, probably making quite the mess in the lab, but it proved his hunch. Microwaves could cook food. At this point, Percy realized he was on to something huge. He and his team at Raytheon quickly started developing a practical way to harness microwaves for cooking. The result was the very first microwave oven, which they called the Radarange. And here's the funny part. That first microwave oven wasn't nothing like the little box you've got on your kitchen counter today. It was almost 6 feet tall, weighed about 750 pounds, and cost the equivalent of $50,000 in today's money. Definitely not something you'd pick up at Walmart for 99 bucks. At first, the microwave oven wasn't really marketed to households. It was used in restaurants, ships, and large-scale kitchens where speed mattered. But as technology improved, the ovens got smaller, cheaper, and safer. By the 1970s, they started showing up in ordinary kitchens, and by the 1980s, microwaves had become one of the most common household appliances in the world. Think about how big that is. Percy Spencer's curiosity about a melted candy bar turned into a device that revolutionized cooking for billions of people. Without him, we'd probably still be heating leftovers in the oven for 30 minutes instead of 3. But let's pack up for a second, because there's something about Percy Spencer that makes the story even more inspiring. Remember how I mentioned that he only had a 5th grade education? Well, despite that, he ended up holding over 300 patents in his lifetime. He didn't let lack of schooling stop him. He learned by doing, by experimenting, by being endlessly curious. In a way, Percy Spencer's story is proof that sometimes the most world-changing discoveries come from people who don't follow the traditional path. Now, like with many new inventions, people didn't exactly know how to feel about microwave ovens at first. Some folks thought they were dangerous. After all, microwaves sounded like something that could fry your brain or give you radiation poisoning. There were even rumors that food cooked in a microwave wasn't real food, or that it somehow became radioactive. None of that was true, of course, but it shows how new technology always freaks people out. And yes, there's some truth to the fact that microwaves can be dangerous if misused. After all, they're powerful energy beams. But the ovens are designed with shielding to keep the microwave safely contained. The reality is, microwaves are no more dangerous than your stove. But at the time, that fear made it harder for them to catch on at first. Here's the kicker. Percy Spencer never became a household name, even though his invention changed how we live. Unlike Thomas Edison or Nikola Tesla, you don't hear kids learning about Percy in school. But every single time you reheat leftovers or make popcorn in under 3 minutes, you're using his invention. And honestly, that makes the story even cooler. Percy didn't care about fame. He just cared about solving problems. He once said he didn't want to be remembered as a genius. He just wanted to be remembered as someone who used his curiosity to make life better for people. And in that sense, he succeeded big time. So the next time you toss a frozen burrito into the microwave, take a second to think about Percy Spencer, the self-taught kid who started from a paper mill to the Navy to accidentally discovering a new way to cook, all because he paid attention to a melted candy bar in his pocket. It's proof that sometimes the biggest breakthroughs don't come from long research papers or high-tech labs. They come from curiosity. From paying attention when something weird happens and asking, wait, why did that just happen? Percy did that, and because of him, you don't have to wait half an hour for your lasagna to heat up. Pretty amazing for a guy who started with nothing but a curious mind.
Alexander Fleming and penicillin. If you've ever taken antibiotics for an infection, you owe your life, quite literally, to a guy named Alexander Fleming. And here's the kicker. His discovery of penicillin, the first true antibiotic, was almost completely an accident. In fact, he was so notoriously messy in the lab that some people joked cleanliness might have cost the world its most important medicine. Let's rewind to the 1920s. Medicine back then was a different world. If you got a serious bacterial infection, like pneumonia, strep throat, or even a small infected cut, you were in big trouble. Doctors could try disinfectants, surgery, or just let your immune system fight it out. But more often than not, people died from infections we consider minor today. Something as simple as a scratch from a rusty nail or a bad sore throat could be a death sentence. Now, here comes Fleming. He was a Scottish bacteriologist working at St. Mary's Hospital in London. Smart guy, but not exactly the neat freak type. His lab was known for being cluttered with petri dishes stacked everywhere. And honestly, this is where fate stepped in. In September 1928, Fleming returned from a holiday and started cleaning up the dishes he'd left behind. On one of those dishes where he'd been growing colonies of a bacteria called Staphylococcus aureus, he noticed something strange. A patch of mold had accidentally contaminated the dish. But instead of just tossing it out, he leaned in closer. The mold wasn't just sitting there. It had actually killed the bacteria surrounding it. There was this clear zone around the mold colony where the bacteria refused to grow. Fleming immediately thought, that's odd, but maybe important. The mold, as it turned out, was a strain of Penicillium notatum. And that little accident led to the discovery of penicillin, the world's first true antibiotic. Think about how big this was. Before penicillin, doctors basically had no way to directly fight bacterial infections. After penicillin, suddenly humanity had a weapon to treat everything from syphilis to strep throat, pneumonia, scarlet fever, and infected wounds. It was like flipping the switch on modern medicine. But here's the thing. Fleming didn't immediately see penicillin's full potential. He wrote a paper about his discovery in 1929, describing how the mold secreted something that could kill bacteria. But producing it in large quantities, stabilizing it so it could be used as a drug, that part was way beyond what Fleming could manage at the time. So, for more than a decade, penicillin kind of sat in the background, known to a few scientists, but not being widely used. Fast forward to the 1940s. The world was deep in World War II, and soldiers were dying from infected wounds as much as from bullets. That's when a team at Oxford, led by Howard Florey, Ernst Chain, and Norman Heatley, picked up Fleming's dusty old research. They worked like crazy to figure out how to purify and mass-produce penicillin. By the time D-Day happened in 1944, Allied soldiers were being treated with penicillin, saving countless lives on the battlefield. So while Fleming discovered penicillin, it took this second team to turn it into a usable drug. And that raises an interesting point. Discoveries aren't always the work of one person in a flash of brilliance. Sometimes it's teamwork across years, with different people building on each other's work. Fleming's role was noticing the mold. The Oxford team's role was making sure it actually got into patients. Without both steps, antibiotics might have come decades later. And let's not forget the ripple effect. Once penicillin was unleashed, it changed everything. Suddenly, medicine had a template for developing other antibiotics: streptomycin, tetracycline, erythromycin. The list goes on. Together, these drugs have saved hundreds of millions, maybe even billions of lives. Life expectancy shot up, surgeries became safer, childbirth became less risky, all because of one moldy dish left out on a cluttered workbench. Now, here's a little twist. Fleming himself was pretty humble about the whole thing. When he accepted the Nobel Prize in 1945, shared with Florian Chain, he warned the world about something we still struggle with today: antibiotic resistance. He basically said, look, if people misuse this drug, like taking it when they don't need it or not finishing their prescriptions, bacteria will adapt and these wonder drugs will stop working. And he was right. Decades later, we're facing superbugs that don't respond to antibiotics, all because of overuse and misuse. It's wild to think that Fleming foresaw this problem before penicillin was even widely available. He knew from day one that medicine is a double-edged sword. Life-saving when used wisely, dangerous when abused. So what makes this story stick? I think it's the humanity of it. Fleming wasn't trying to be a hero. He wasn't even particularly tidy or methodical. He just noticed something unusual and stayed curious enough to ask, what's going on here? That's the same spark of curiosity that drove Wilhelm Röntgen to X-rays and Percy Spencer to microwaves. Sometimes science doesn't happen in a thunderclap of brilliance. It happens when someone pays attention to an accident. And if Fleming had been a little more organized, if he had thrown out that moldy dish without looking, who knows how much longer humanity would have waited for antibiotics? How many lives would have been lost in the meantime? So the next time you're prescribed antibiotics for something simple like strep throat, pause for a second and think about Alexander Fleming and his messy lab bench. Without him, you might not have that life-saving pill in your hand. You might not even be alive at all. And that, to me, is what makes Fleming's story incredible. Not that he was the smartest scientist in the room or the most organized, but that he paid attention when most people wouldn't have. A moldy dish that should have been trash ended up saving the world.
Hans Christian Ørsted and electromagnetism. Picture this. It's the early 1800s, and science is in a kind of identity crisis. Electricity and magnetism are known, but they're thought of as totally separate phenomena. Electricity? That's sparks, lightning, shocking frogs' legs in weird experiments. Magnetism? That's compasses pointing north and mysterious forces pulling metal objects. Nobody really connected the two. Enter Hans Christian Ørsted, a Danish physicist and chemist who wasn't afraid to experiment in ways others might have dismissed as unimportant. And just like Fleming with his moldy dish, Ørsted stumbled onto something by accident. But instead of antibiotics, he uncovered a connection that powers practically everything in our modern world. Here's how it happened. It was 1820, and Ørsted was giving a lecture to students at the University of Copenhagen. He wanted to demonstrate how electrical currents worked, so he set up a simple experiment with a battery and a wire. A compass happened to be nearby on the table. Some say he deliberately placed it there, others say it was just part of the clutter. Either way, as soon as he turned on the current, something strange happened. The compass needle, which should have been pointing north, twitched. Wait, what? Ørsted noticed that whenever electricity flowed through the wire, the compass needle moved, and not just randomly. It moved in a way that suggested the current was generating a magnetic field. Suddenly, electricity and magnetism weren't strangers anymore. They were part of the same phenomenon. This was the birth of electromagnetism. Think about how massive this was. Before Ørsted, electricity was just a parlor trick. People made sparks and shocked themselves at parties to amuse guests. Magnetism was for navigators trying to cross the ocean. But Ørsted's discovery tied them together in a way nobody could ignore. Now let's pause here for a second. Imagine being a student in that lecture hall. You came in expecting a boring demo about batteries, and suddenly your professor casually changes the course of science forever. The needle on a compass jumping because of an electric current might sound small,
but it laid the foundation for basically every electrical technology we have today. Without Ørsted, there's no electromagnets, no motors, no generators, no transformers, no MRI machines. Heck, you wouldn't even be watching YouTube without this discovery, because every computer, phone, and TV screen depends on principles of electromagnetism. But here's the cool part. Ørsted didn't completely understand what he had uncovered. He knew electricity could create magnetism, but he didn't develop the mathematical framework. That came later, thanks to scientists like André-Marie Ampère, Michael Faraday, and eventually James Clerk Maxwell. Maxwell, in particular, turned these experimental results into a set of equations that literally described the behavior of light, radio waves, and electromagnetism as a whole. Ørsted lit the spark, but others turned it into a firestorm of discovery. Still, credit where credit is due, Ørsted was the first to bridge the gap. He took two separate mysteries and showed they were connected. And isn't that how so many great discoveries happen? Not by inventing something totally new, but by linking things that already exist in a way nobody thought to before. Now, here's something fun you might not know. Ørsted wasn't just a scientist. He was also a philosopher, heavily influenced by Romanticism, the artistic and intellectual movement of the time. Romantics loved the idea of unity in nature, the belief that all natural forces were connected, even if humans hadn't yet figured out how. Ørsted's experiments weren't just about fiddling with wires. They were about chasing this bigger vision that nature's forces must somehow be related. In a way, his discovery of electromagnetism was as much philosophy as it was science. And speaking of influence, let's zoom out for a second. If Ørsted hadn't noticed that twitching compass needle, how different would the world look today? No electromagnets means no electric motors. No motors means no washing machines, no fans, no cars as we know them. No generators means no easy way to produce electricity, which means no power grids. Forget computers, forget smartphones, forget streaming platforms. Modern life is essentially built on electromagnetism, and it all started with one Dane giving a lecture in 1820. Of course, the discovery didn't stay in Denmark. Scientists across Europe picked it up and ran with it. Ampère studied how electric currents create magnetic fields between wires. Faraday took it further, showing that magnetic fields can also produce electricity, what we call electromagnetic induction. Put those together, and you've got the recipe for power plants, spinning magnets inside coils of wire to generate electricity. That's literally how we power cities today. Ørsted himself stayed modest. He continued teaching, continued experimenting, and even dabbled in chemistry. Fun fact, he's also credited with first isolating aluminum as a metal in 1825, which is wild, considering how important aluminum is for everything from airplanes to soda cans. But it's his work with electricity and magnetism that secured his place in history. Now, let's humanize this guy a little bit. Ørsted wasn't some superhero genius working in isolation. He made his discovery in the middle of an ordinary lecture. He wasn't aiming to revolutionize science. He was just trying to show students something cool with a battery. That makes it all the more relatable, right? Sometimes history's biggest breakthroughs don't happen in brand labs or during epic research projects. They happen when someone curious enough notices a weird little thing and decides not to ignore it. And think about the domino effect. Ørsted's compass needle twitch led to Faraday's generators, which led to Edison's light bulbs, which led to Tesla's alternating current, which led to power grids, which led to, well, you sitting here right now with a device in your hand or on your desk running on electricity. All because one professor paid attention when most people might have just shrugged.
So, the next time you charge your phone, flip on a light switch, or listen to music blasting from your speakers, give a little nod to Hans Christian Ørsted, because without him, electricity and magnetism might have stayed strangers for decades longer. And without their union, the modern world simply wouldn't exist.
Joseph Priestley and carbonated water. When you crack open a can of soda and hear that satisfying psst, you're actually hearing the result of a discovery made over 250 years ago. And get this, the man behind it, Joseph Priestley, wasn't even trying to invent a drink. He was a curious chemist poking around in a brewery. Let's set the stage. The year is 1767. Priestley was an English scientist, philosopher, and clergyman. This was a guy with endless curiosity. He dabbled in electricity, chemistry, politics, even theology. He's most famous for discovering oxygen. We'll get to that in another story. But one of his earliest and quirkiest discoveries was carbonated water, the direct ancestor of every soda, seltzer, and fizzy drink you've ever had. Here's how it happened. Priestley lived near a brewery in Leeds, England. And breweries, as you can imagine, were full of big vats of fermenting beer. Fermentation gives off lots of carbon dioxide gas, which just kind of hovers over the beer. Most people would have ignored it, but Priestley wasn't most people. He started wondering, what happens if I trap this gas? What if I dissolve it into water? So he got creative. He suspended a bowl of water over one of the fermenting vats and let the gas bubble through it. The result? Water that tasted, well, different. It had a tangy, sparkling sensation that was unlike regular water. Priestley had just invented soda water. At first, he didn't think of it as a fun drink. He was a man of science, after all, so he focused on the chemistry. In 1772, he published a paper with the catchy title, Impregnating Water with Fixed Air. They had a way with words back then, huh? In the paper, he described how to infuse water with carbon dioxide to make it fizzy. Now, here's where things get interesting. Priestley thought carbonated water might actually be healthy. He believed it could preserve meat, cure scurvy, and help with digestion. Remember, this was the 1700s. Medicine was more guesswork than science. But his idea caught on, and soon soda water wasn't just a chemistry trick. It was being marketed as a health drink. Fast forward a bit, and another man named Johann Jacob Schwepp took Priestley's idea and turned it into a business. Yes, that's Schwepp. In the 1780s, Schwepp developed a practical way to mass-produce carbonated water, and he founded the company Schweppes, which you can still find in grocery stores today. Priestley laid the scientific foundation, and Schwepp made it commercially viable. Together, they set the stage for the entire soda industry. And let's be real, the impact of this discovery is everywhere. Carbonated water evolved into soft drinks, tonic water, ginger ale, colas, energy drinks, sparkling waters, you name it. The global soda industry today is worth hundreds of billions of dollars, all because one curious scientist thought, what if I mix this mysterious gas into water? But Priestley's story doesn't stop there. His carbonated water invention also had unexpected spin-offs. During long sea voyages, sailors battled scurvy, a disease caused by vitamin C deficiency. Some thought fizzy water could help prevent it. Spoiler, it didn't cure scurvy, but it did encourage experimentation with flavored carbonated waters, which eventually led to adding fruit syrups and sugars. And boom, soda as we know it was born. There's also a fun what if to think about here. Imagine if Priestley hadn't lived near a brewery. If he hadn't noticed that invisible gas hanging around fermenting beer, would we still have carbonated drinks today? Probably, but maybe decades later. And who knows, maybe the entire soda industry would have looked completely different. Now, let's zoom in on the human side of this discovery. Priestley wasn't just some nerd in a lab coat. He was incredibly curious about the natural world, and he believed science should improve everyday life. He didn't see a wall between serious science and fun discoveries. To him, turning plain water into something sparkling and new was just as worthy of study as discovering gases or experimenting with electricity. That mindset is important because a lot of the things we take for granted today, like soda, came from scientists willing to explore ideas that seemed trivial. Think about it. When Priestley made his first batch of fizzy water, it probably seemed like nothing more than a quirky novelty. But little novelties sometimes spark entire industries. And honestly, carbonated water is more than just a drink. It shaped social culture, too. By the 1800s, soda fountains became popular gathering spots in the U.S. They were the coffee shops of their day, where people met up to sip fizzy drinks flavored with fruit syrups. Later, cola companies like Coca-Cola and Pepsi turned soda into a global phenomenon, tying it to everything from advertising to pop culture to politics and identity. All of that traces back to Priestley. But here's a detail most people don't realize. Priestley didn't actually profit much from his discovery. He wasn't in it for money, he was in it for knowledge. In fact, his life was often turbulent. His political and religious views made him enemies, and at one point his house and laboratory were burned down by a mob. He eventually fled England and moved to the United States. Through it all, though, his curiosity never dimmed. He just kept exploring, kept experimenting. And that's why I love the story of Joseph Priestley and soda water. It's not just about a guy inventing fizzy drinks. It's about the spirit of curiosity. The idea that even the most ordinary question, what happens if I bubble this gas into water, can lead to discoveries that ripple across centuries. So the next time you open a can of Coke, sip a LaCroix, or enjoy a fizzy cocktail, remember that you are tasting a piece of history. You're literally enjoying the curiosity of a man standing over a beer vat in 1767, letting bubbles transform plain old water into something extraordinary. Joseph Priestley may not have known he was sparking a billion-dollar industry, but he definitely knew one thing: science is everywhere, even in the bubbles rising from a drink.
Friedrich August Kekulé and the benzene ring structure. Some discoveries are born from experiments. Some are born from accidents, and then there are the rare ones that come from dreams. That's the case with Friedrich August Kekulé, a German chemist in the 19th century who figured out the structure of benzene, one of the most important molecules in all of chemistry, because of a vision he had while half asleep. Let's rewind to the mid-1800s. Chemistry was booming, but it was still a bit like a puzzle with missing pieces. Scientists were beginning to understand atoms and how they bonded together to form molecules, but some substances were stubborn mysteries. Benzene was one of them. Benzene is a simple hydrocarbon made of carbon and hydrogen, but it didn't behave like any other molecule known at the time. Its formula was clear: C6H6. 6 carbons, 6 hydrogens. But here's the problem. By the rules chemists understood back then, that formula didn't make sense. The atoms shouldn't fit together so neatly. And yet benzene was a real substance, showing up in coal tar and proving to be very stable. It didn't match the patterns scientists had for other molecules. It was a riddle that drove people nuts. Enter Kekulé. He was already respected in chemistry. especially for his work on organic structures. He believed that carbon atoms could form chains by bonding to each other, an idea that revolutionized the way chemists thought about molecules. But benzene was a different beast. No chain model seemed to work. And here's where the dream comes in. One evening in the 1860s, Kekulé was dozing by the fire. He later described how he drifted into a sort of half-conscious state, thinking about atoms and molecules swirling around in his mind. Suddenly, he imagined them as little dancing shapes, twisting and turning. Then he saw something remarkable, a snake circling around until it grabbed its own tail. That image, the ancient symbol known as the Ouroboros, gave Kekulé the inspiration he needed. What if benzene wasn't a straight chain of carbons at all? What if it was a ring? 6 carbon atoms linked in a closed loop with alternating single and double bonds, and 1 hydrogen attached to each carbon. And just like that, the mystery of benzene began to make sense. The ring structure explained why benzene was so stable and why it behaved differently from other hydrocarbons. Kekulé announced his idea in 1865, and although chemists later refined the details, eventually developing the concept of resonance to describe benzene's electron distribution, Kekulé's vision of the ring was the breakthrough everyone had been waiting for. Now let's pause here for a second. Can you imagine being a scientist in the 1800s and standing up at a lecture to say, "Oh yeah, I figured it out because I dreamed of a snake biting its tail"? That takes guts. But Kekulé wasn't embarrassed. He embraced the story. In fact, he told it at a dinner years later, charming his fellow chemists with the tale of how a dream solved one of science's biggest puzzles. And here's why this matters to you, sitting here in the 21st century. Benzene isn't just some obscure chemical. It's everywhere. The discovery of its structure opened the floodgates to an entire branch of chemistry: aromatic compounds. These are molecules based on the benzene ring, and they form the backbone of modern organic chemistry. Without Kekulé's insight, you wouldn't have things like plastics. Benzene rings are in polystyrene, nylon, and countless synthetic materials. Pharmaceuticals. Many drugs, from aspirin to antibiotics, are built on benzene-based structures. Dyes and paints. The vibrant colors of synthetic dyes in clothing and art, all thanks to aromatic chemistry. Explosives. Yes, even TNT is built on a benzene framework. Fuel and solvents. Benzene and its derivatives power engines and serve as industrial workhorses. Basically, Kekulé's dream helped build the modern world, from medicine to fashion to technology. But there's another layer to this story. Kekulé's benzene discovery shows how science isn't always cold logic and strict equations. Sometimes it's messy, sometimes it's intuitive, and sometimes it even happens in dreams. Creativity and science aren't opposites, they feed each other. Kekulé's snake wasn't proof in itself, but it gave him the mental spark to test the ring idea in real chemistry. And once the experiments backed it up, the dream became a discovery. Of course, not everyone was thrilled right away. Science always has skeptics. Some chemists questioned whether the ring model was real or whether Kekulé was just seeing patterns that weren't there.
But over time, experimental evidence piled up, and the benzene ring became accepted as one of the cornerstones of chemistry. Now let's humanize this guy. Kekulé wasn't a lone mad scientist scribbling equations on the wall. He was part of a community of chemists, working at a time when the field was exploding with new ideas. His vision of carbon atoms linking into chains and eventually into rings gave chemistry a framework that scientists still use today. And you know what's funny? He wasn't the only one who had dream-inspired insights. Dmitri Mendeleev, the creator of the periodic table, also claimed that the arrangement of elements came to him in a dream. It's almost like the subconscious mind, when left to wander, connects dots the waking brain can't. Kekulé's snake is one of the best examples of that. But here's the kicker. Even if Kekulé hadn't had that dream, someone else probably would have cracked the benzene puzzle eventually. Science has a way of converging on truths. Still, the fact that it happened the way it did makes the story unforgettable. It's not just a discovery. It's a story about imagination, symbolism, and the strange ways the human brain solves problems. So, the next time you're sipping from a plastic bottle, popping a pill, or wearing brightly dyed clothes, think of Friedrich August Kekulé, dozing by the fire, dreaming of a snake biting its tail. That one image, plucked from the depths of his subconscious, changed chemistry forever. And maybe it's a reminder for all of us. Sometimes the answers you're chasing won't come when you're forcing them. Sometimes they show up when you let your mind drift, when you're half asleep, or when you're daydreaming. Science isn't always about strict control. It's also about giving your imagination space to play.
Spencer Silver and the adhesive behind Post-it notes. When you think of big scientific discoveries, your mind probably goes to things like X-rays, vaccines, or electricity. But here's the thing. Sometimes the small discoveries shape our daily lives just as much. Case in point, Post-it notes. You know, those little sticky squares you use to jot down reminders, mark pages in books, or cover your fridge with to-do lists. They might not look like much, but they exist because of a happy accident and a chemist named Spencer Silver who wasn't even trying to make them. Let's rewind to the 1960s. Silver was working at 3M, the big American company known for innovation in materials and adhesives. At the time, he wasn't trying to invent a new office supply. His actual project was much more ambitious. He wanted to develop a super strong adhesive, something powerful, something that could hold things together better than ever before. But here's the twist. Instead of inventing a superglue, he ended up with the exact opposite. His adhesive was weak, almost laughably weak. It would stick to surfaces, but only lightly. You could peel it right off without damaging the surface or leaving a residue. Now, most people would have looked at that and said, well, that's a flop, back to the drawing board. But Silver wasn't most people. He thought, maybe there's a use for this kind of adhesive. Something temporary, something reusable. The problem was he couldn't figure out what that use was. For years, he gave talks inside 3M about his solution without a problem. He kept promoting the adhesive, showing colleagues that it was unique and special, but nobody had a clear application for it. Imagine pitching an idea to your coworkers over and over again, only to have everyone nod politely and move on. That was Silver's reality. And then enter Art Fry, another 3M scientist. In the mid-1970s, Fry sang in his church choir and had a very practical problem. He used little scraps of paper as bookmarks in his hymn book, but they kept falling out. He wanted something that would stick in place, but not permanently, something he could reposition without damaging the pages. That's when he remembered Silver's weird adhesive. Fry started experimenting, applying the weak glue to little pieces of paper, and just like that, the idea for Post-it notes was born. Paper that could stick lightly, be peeled away, and then reused. It was simple, practical, and oddly addictive. But here's the kicker. Even after they had the product, 3M wasn't convinced it would sell. At first, the company struggled to market Post-it notes. Who would pay for little sticky papers? It sounded almost too trivial. So in 1977, 3M did something clever. They gave away free samples in Boise, Idaho to see what people thought. The response? People loved them. Once they'd tried Post-its, they couldn't go back. Demand exploded. By 1980, Post-it notes launched nationwide, and they've been a staple of desks, offices, and homes ever since. Think about that for a second. A weak, failed adhesive turned into one of the most successful office supplies in history. And Silver, the guy who made the glue, didn't invent Post-it notes on his own. It took Art Fry's everyday frustration to connect the dots. Their collaboration is a perfect reminder that innovation isn't always about one genius moment. It's about persistence, teamwork, and sometimes just noticing small annoyances in daily life. Now, let's zoom out a bit. Post-it notes aren't just sticky paper. They've shaped how people think, plan, and create. Brainstorming sessions covered in colorful Post-its, writers mapping out stories, Post-its, students organizing their study notes, Post-its. Even tech companies like Google have famously used walls full of Post-its to develop new products. That little yellow square became a tool for human creativity. And here's something funny. The original color, yellow, wasn't chosen for deep marketing reasons. It was just the scrap paper that happened to be available at the lab next door to Fry's office. Pure coincidence. Yet now, when you imagine a sticky note, you automatically picture yellow. That's how iconic it's become. Another neat twist. Spencer Silver himself admitted that his adhesive wasn't exactly glamorous compared to other inventions. He once joked that nobody would ever write a book about his life because what did he do? I made glue. But here's the thing. His glue changed the way people work, collaborate, and organize their thoughts. Sometimes impact isn't measured by size, but by ubiquity. And if we're being real, Post-it notes are a brilliant example of how human psychology plays into invention. Why do we love them so much? Because they're low on commitment. You can jot something down, stick it somewhere, and remove it later without consequences. It feels temporary, flexible, forgiving. That's the exact opposite of writing in pen on a permanent sheet of paper. The weak adhesive wasn't a failure. It was the whole point. Silver's story also teaches another big lesson. Don't dismiss so-called failures too quickly. He could have thrown away that adhesive formula in frustration and moved on. But instead, he believed in it, even when he didn't know what it was for. Innovation often comes from that kind of stubborn belief, holding on to an idea until the right context reveals itself. Sadly, Spencer Silver passed away in 2021, but his legacy is in every office drawer, every classroom desk, every brainstorming session covered in neon notes. Millions of people interact with his invention every day without even knowing his name. That's kind of poetic, isn't it? A humble, quiet invention that makes life just a little easier.
Charles Goodyear and vulcanized rubber. Okay, so let me throw a question at you.
When was the last time you thought about rubber? Not much, right? Maybe when you got a flat tire, or when you were stretching a rubber band that snapped and stung your fingers. But here's the thing. Rubber is everywhere. Tires, shoes, hoses, seals, gloves, sports balls, you name it. And the reason rubber became practical, durable, and essential to the modern world? That's all thanks to a man named Charles Goodyear and his discovery of vulcanized rubber. But here's the kicker. Goodyear didn't stumble onto this discovery in a fancy lab with funding and recognition. Nope. He was broke, he was ridiculed, and he was obsessed with rubber to the point where it basically ruined his life. His story is both inspiring and kind of tragic, but it shows what happens when someone refuses to give up on a crazy idea. Let's back up a bit. Rubber comes from the sap of rubber trees, and people in South America had been using it for centuries before Europeans even knew it existed. When explorers brought it back in the 1700s, it seemed magical. Here was this stretchy, waterproof material, perfect for raincoats and boots and other products. But there was a big, embarrassing problem. Raw rubber was unstable. In cold weather, it became stiff as a board. In hot weather, it melted into a gooey, smelly mess. Imagine leaving your shoes out in the sun and coming back to find them melted like cheese on a pizza. That was the state of rubber in the early 1800s. Enter Charles Goodyear. He was a poor man with no formal scientific training, but he became obsessed with fixing rubber's flaws. He believed, almost religiously, that rubber had incredible potential, if only he could figure out how to make it stable. His obsession began after seeing a rubber life preserver in a store. He was captivated, and from then on, rubber became his life's mission. But Goodyear's obsession didn't exactly pay the bills. In fact, it plunged his family into poverty. He sold furniture, borrowed money, even went to debtor's prison multiple times, all while experimenting with rubber in his kitchen. His wife and kids often suffered because of his single-minded pursuit. Neighbors thought he was crazy, and honestly, he probably looked it. Boiling batches of rubber over stoves, making terrible smells, and producing nothing useful. For years, Goodyear tried every possible trick. He mixed rubber with different chemicals, heated it, froze it, stretched it. Nothing worked. The material always reverted back to being stiff or sticky. Most people would have given up after the 100th failure, but not Goodyear. He kept at it, driven by this almost irrational belief that rubber could be tamed. And then came the breakthrough. One day in 1839, while working with rubber mixed with sulfur, Goodyear accidentally dropped a piece onto a hot stove. Instead of melting into a gooey mess, the rubber turned tough and elastic, but it didn't lose its flexibility. It stayed solid, durable, and resilient. Finally, he had it. He discovered what we now call vulcanization, heating rubber with sulfur to stabilize it. That one moment changed everything. Vulcanized rubber didn't stiffen in the cold or melt in the heat. It became a material you could actually rely on, opening the door to thousands of applications. Without it, there would be no car tires, no industrial belts, no waterproof footwear, no sports balls that bounce consistently. It's the kind of discovery that quietly underpins entire industries. But here's the tragic part. Goodyear didn't get rich from his discovery. He patented vulcanization in 1844, but patent wars broke out almost immediately. Other inventors, like Thomas Hancock in England, had been experimenting with similar processes and filed competing patents. Legal battles drained Goodyear's resources, and he never truly profited the way you'd expect from someone who changed the world. By the time he died in 1860, Goodyear was still deeply in debt. He once wrote, I'm not disposed to complain that I have planted and others have gathered the fruits. In other words, he knew he wouldn't get the reward, but he still took pride in the fact that his discovery had changed humanity. Ironically, today, his name is everywhere, on Goodyear Tire and Rubber Company, one of the biggest tire manufacturers in the world. But here's the twist. Goodyear himself had nothing to do with the company. It was founded decades after his death and was simply named in his honor. So the brand made billions, while the man behind the discovery died broke. Talk about unfair. Now think about how huge his contribution really was. The automobile revolution? Impossible without durable tires. Factories and machinery depended on rubber belts and hoses. Everyday life, from sneakers to erasers to raincoats, got a massive upgrade because one man refused to stop tinkering in his kitchen. Even space exploration uses vulcanized rubber components. The modern world literally runs on Goodyear's discovery. And here's the part I find most fascinating. His discovery wasn't pure genius in the lab. It was a mix of obsession, accident, and persistence. He didn't set out with a perfect plan. He just kept failing, learning, and trying again until chance and preparation collided. That's often how breakthroughs happen. So the next time you see a bouncing basketball, ride in a car, or even snap a rubber band around a stack of papers, give a thought to Charles Goodyear, the man who endured poverty, ridicule, and endless failure, all to give us a material that holds modern life together, literally. His story is both a cautionary tale and a lesson in persistence. It shows the cost of obsession, but also the incredible impact one determined individual can have. Goodyear didn't get the riches, but he did get something arguably greater: immortality. His name will be remembered as long as rubber keeps the world moving.
Jean-Pierre Sauvage and molecular chains. All right, let's talk about a discovery that sounds like it was pulled straight out of a futuristic novel. Molecular chains, or, to be more precise, mechanically interlocked molecules. The man behind this breakthrough? A French chemist named Jean-Pierre Sauvage. Now, I know what you might be thinking. Mechanically interlocked molecules. That sounds like some high-level sci-fi jargon. But hang tight, because not only is it real, it's already reshaping what's possible in the world of nanotechnology, and it might one day change your life in ways you can't even imagine. So who is Sauvage, and what exactly did he do? Back in the early 1980s, Sauvage and his research team were studying how molecules could be joined together. In chemistry, molecules usually connect through chemical bonds, electrons shared between atoms, the usual stuff we all vaguely remember from high school. But Sauvage managed to do something way cooler. He created molecules that weren't just chemically bonded, but physically linked together like tiny chains. Imagine two rings of atoms interlocked like links in a necklace. That's what he pulled off. This was a big deal because until then, the idea of making molecules hold hands mechanically rather than through traditional bonding seemed almost impossible. Yet Sauvage figured out how to design and control them. It's like he reached into the molecular world and built Lego pieces that could snap together, not with glue, but with the way they physically intertwined. Now, you might be asking, okay, cool, but what's the point? Why does it matter if molecules are linked like chains? Great question. Here's the mind-blowing part. Once you start chaining molecules together, you can make them move in relation to each other.
That means you're no longer just building static substances like plastic or steel. You're building molecular machines. Think about that. Machines made not of gears and bolts, but of molecules, each one thousands of times smaller than the width of a human hair. And these machines can do things like rotate, bend, and switch states when you give them energy. In other words, they could one day act like microscopic robots. Savage's breakthrough opened the door to a whole new field, molecular nanotechnology. After his discovery, other chemists like Fraser Stoddart and Bernard Feringa expanded on it, designing molecular shuttles and motors. In fact, the three of them, Savage, Stoddart, and Feringa, shared the 2016 Nobel Prize in Chemistry for this pioneering work. The Nobel Committee even called their creations the world's smallest machines. Now, let's get practical. What could molecular machines actually do? The possibilities are wild. Imagine tiny molecular robots traveling through your bloodstream, delivering drugs directly to diseased cells like guided missiles. Picture new materials that can heal themselves when damaged because their molecular structures can rearrange on command. Or think about electronics so small and efficient that we can cram supercomputers into things no bigger than a grain of rice. And this isn't just fantasy. We're already seeing prototypes of these ideas in labs today. Scientists are experimenting with molecular machines that can drill into cancer cells and destroy them from the inside, or nanoscopic switches that could revolutionize data storage. Savage's discovery of interlocked molecules is basically the starting pistol for an entirely new technological revolution. But here's what I find especially fascinating. Like many great scientific breakthroughs, Savage's discovery started as pure curiosity. He wasn't sitting there in 1983 thinking, I'm going to change medicine, computing, and materials science forever. He was just exploring the boundaries of chemistry, asking what's possible when you push molecules beyond their usual behavior. That's the beauty of science. Sometimes the wildest applications come decades later from discoveries that seemed impractical at the time. And let's give Savage some credit as a human being, too. He wasn't some flashy, headline-hungry scientist. He's a quiet, meticulous chemist who spent decades building knowledge piece by piece. His colleagues often describe him as humble and deeply collaborative, the kind of guy more excited about molecules than fame. Even after winning the Nobel Prize, he kept stressing that this was just the beginning, that molecular machines were still in their infancy, and the real revolution was yet to come. Think about it this way. In the 1800s, when Charles Babbage and Ada Lovelace were tinkering with early computing concepts, they couldn't imagine the smartphone in your pocket. In the same way, Savage's interlocked molecules might seem niche right now, but give it 50 or 100 years, and we could be living in a world where nanomachines built on his discovery are as common as electricity. Here's a fun metaphor. If normal chemistry is like building with bricks, Savage's work is like discovering gears. Suddenly, you don't just have walls and buildings, but you can have moving parts, engines, and machinery. That's the scale of his impact. Of course, as with all great scientific breakthroughs, there are challenges. Building molecular machines is still incredibly complex. Controlling them in real-world environments, like inside the human body, is even harder.
And then there's the ethical question. What happens if we create molecular robots that can replicate or behave unpredictably? It's the stuff of both hope and sci-fi horror stories. But every big leap in science comes with risks, and the potential benefits here are enormous. So next time you hear the word nanotechnology, remember Jean-Pierre Sauvage. Remember the chemist who figured out how to make molecules hold hands like tiny chains, and in so doing, unlock the possibility of machines that are smaller than we can even see. It's not just chemistry. It's the beginning of a whole new way of building, healing, and thinking about the future. In a way, Savage's discovery is the perfect example of why curiosity matters. He wasn't chasing money or glory. He was chasing understanding. And that curiosity led to a discovery that could one day save lives, revolutionize industries, and completely transform the way humans interact with the microscopic world. Not bad for a few molecules playing with each other, right?
William Perkin and the first synthetic dye, mauve. Let me paint you a picture. It's the mid-1800s, and fashion is everything. Rich people are competing with each other in balls and banquets, and what you wear says everything about your status. One of the most prized colors? Purple. But here's the catch. Making purple dye was insanely expensive. Traditionally, it came from crushing thousands of sea snails called murex. We're talking about an ancient practice that dates all the way back to the Phoenicians. Because it was so hard to make, purple became the royal color. Kings, queens, emperors, they wore it to show their power. Everyone else? Too bad. Too broke. Now, enter a young teenager named William Perkin. In 1856, Perkin was just 18 years old, studying chemistry in London under the famous scientist August Wilhelm von Hofmann. His original goal wasn't fashion or dyes. He wanted to cure malaria. At the time, the best treatment for malaria came from quinine, a compound extracted from the bark of a South American tree. Quinine was rare and expensive, so scientists were desperately trying to find a way to synthesize it in a lab. So here's Perkin working away in his home lab over Easter break. Yep, even his vacations were nerdy. He was experimenting with coal tar, a thick, sticky byproduct of coal gas production, hoping he could somehow turn it into artificial quinine. Spoiler alert, he didn't succeed. But what he did stumble upon was way more colorful. Instead of quinine, he ended up with the blackish sludge. Most people would have tossed it out in frustration, but Perkin, being curious, decided to clean his beaker with alcohol. To his surprise, the solution turned a brilliant purple. He realized that he had accidentally created a dye, one that was vivid, stable, and unlike anything people had seen before. He called it mauvine, after the French word mauve for the mallow flower, which has purplish petals. It was the first synthetic dye in history, and it was about to turn the fashion world upside down. Here's why it mattered. Natural dyes at the time were expensive, inconsistent, and faded quickly.
But Perkins' Movine was cheap, could be produced in large quantities, and held its color well. Suddenly, purple was no longer the exclusive property of kings and queens. Ordinary people could wear it too. Fashion was democratized by a chemistry accident. And it didn't stop there. Perkin, being smart, saw the potential immediately. With help from his father and brother, he patented the dye and set up a factory to mass produce it. This was revolutionary. Imagine being 18, stumbling upon a discovery in your messy home lab, and then launching a whole new industry from it. By the late 1850s, mauve-colored dresses were all the rage, especially after Queen Victoria herself wore a mauve down to a royal exhibition. When royalty sets a trend, the world follows. Perkin basically kick-started the synthetic dye industry, which in turn sparked the broader chemical industry. Think about it. Once people realized coal tar could make not just mauve, but a whole rainbow of colors, chemists around the world rushed to experiment. Soon, synthetic dyes replaced most natural ones. But it didn't stop at fashion. The dye industry eventually led to the development of modern pharmaceuticals, plastics, and materials. In fact, the very research Perkins sparked with dyes ended up feeding back into medicine, which is kind of funny, considering he was originally trying to make a drug for malaria. Now, here's the personal side. Perkin was only 18 when he made this discovery. Most 18-year-olds are worried about exams or their first job. He was founding industries. By his mid-20s, he was wealthy and famous. He could have stopped there, but he kept pushing chemistry forward. Even after selling his dye business later in life, he went back into research and made further contributions, including improvements in dyeing processes and organic chemistry. Let's not forget the cultural impact. Mauve wasn't just a color. It became a symbol of modernity, of the new industrial world where science could shape fashion and culture. Newspapers at the time even talked about mauve mania. People couldn't get enough of it. And while it might sound silly now, obsessing over a shade of purple, it was a clear sign that the world was entering a new era where chemistry and everyday life were going to be inseparable. And here's a fun detail. Movine wasn't a perfectly stable dye compared to the synthetic dyes that came after it. Eventually, other chemists developed better, longer-lasting colors, and mauve fell out of style. But by then, the genie was out of the bottle. Perkin had proven that synthetic chemistry could outcompete nature, and the modern chemical industry never looked back. Think about the ripple effect. Synthetic dyes led to synthetic fabrics, synthetic medicines, synthetic everything. The chemical revolution powered by Perkins' Movine is one of the foundations of the modern world. Even your phone case, your sneakers, and the pills in your cabinet owe something to that happy accident with coal tar in 1856. Perkin lived long enough to see his impact recognized. On the 50th anniversary of Movine's discovery in 1906, he was celebrated with honors and awards, even knighted by King Edward VII. Not bad for a teenager whose failed experiment turned the world purple. So, the next time you put on a brightly colored t-shirt or see a neon sign glowing in the night, think back to William Perkin. He's proof that sometimes failure isn't failure at all. It's just success in disguise. And sometimes the most world-changing discoveries come not from reaching your original goal, but from noticing something beautiful in the mess you made along the way.
Rosalind Franklin, key to discovering DNA's double helix structure. All right, let's talk about DNA. Everyone today knows it's the blueprint of life, those famous twisting ladders of genetic code that decide everything from your eye color to whether you can curl your tongue. But for most of human history, we didn't know what DNA even looked like. We knew it was important, but the actual structure? That was a mystery. And that's where Rosalind Franklin comes in. Rosalind Franklin was a brilliant chemist and crystallographer in the 1940s and 50s. Crystallography is basically the science of shining X-rays at crystals, or in this case, biological molecules, and studying the patterns the rays make when they scatter. Think of it like taking a shadowy X-ray picture of something way too small to see with normal microscopes. It's incredibly tricky work, requiring patience, precision, and a deep understanding of both physics and chemistry. At King's College London, Franklin was tasked with studying DNA using this method. Now, DNA at the time was just this mysterious substance. Scientists knew it carried genetic information. Experiments had shown that much. But what shape did it take? That was the burning question. Some thought it might be a simple chain. Others thought it was more like a triple helix. Nobody had nailed it down. Franklin, with her sharp mind and meticulous approach, started producing some of the clearest X-ray diffraction images of DNA ever seen. And then came Photo 51. Photo 51 wasn't just any snapshot, it was the smoking gun. Captured by Franklin's graduate student, Raymond Gosling, under her guidance, this image revealed a cross-shaped pattern that could only mean one thing. DNA had a helical structure. More specifically, it was consistent with a double helix. Now, here's where things get messy and honestly controversial. Franklin's colleague at King's, Maurice Wilkins, showed Photo 51 to James Watson without her permission. Watson and Crick were already racing to crack the DNA code. When Watson saw that image, it was like a light bulb moment. It gave him and Crick the critical clue they needed to finalize their famous double helix model of DNA in 1953. To be clear, Watson and Crick were brilliant scientists in their own right, but Franklin's data was essential. Without her painstaking work, they might not have gotten there when they did. Yet when Watson, Crick, and Wilkins published their famous papers in Nature, Franklin's contribution was downplayed. She was given some acknowledgement, but not nearly the credit she deserved. It gets even sadder. Rosalind Franklin died in 1958 from ovarian cancer at just 37 years old. 4 years later, in 1962, the Nobel Prize for the discovery of DNA structure was awarded, but only to Watson, Crick, and Wilkins. By Nobel rules, prizes aren't given posthumously, so Franklin couldn't have received it anyway. Still, many argue she should have been alive to share in the recognition. But let's step back from the injustice for a second and really appreciate her contribution. Franklin wasn't just a supporting character in the DNA story, she was central. Her ability to capture those X-ray diffraction images with such clarity was unmatched. She combined raw technical skill with scientific insight, and that's what allowed humanity to finally see the structure of life's code. And the impact? Honestly, it's hard to overstate. Understanding DNA structure unlocked modern genetics. It gave us the key to how genetic information is stored, copied, and passed on. From that foundation came everything from genetic testing to forensics to biotechnology to the Human Genome Project. Even today, gene editing tools like CRISPR trace their roots back to that moment of revelation in the early 1950s. Here's another side to Franklin's story that often gets overlooked. She wasn't just about DNA. After leaving King's, she moved to Birkbeck College and did groundbreaking work on viruses. She studied the structure of the tobacco mosaic virus and the polio virus, producing research that laid the groundwork for virology. So even beyond DNA, her fingerprints are on multiple scientific revolutions. Her story has since become a symbol of the struggles women in science have faced, overlooked, undercredited, and sometimes outright dismissed. Watson himself, in his later memoirs, didn't do her reputation any favors, often describing her in less than flattering terms. But history has been kinder. Today, Rosalind Franklin is rightly celebrated as one of the heroes of molecular biology. Buildings, research centers, and scholarships bear her name. And Photo 51 has become an iconic image in the history of science, almost like the Mona Lisa of molecular biology. What I personally find inspiring about Franklin's story is this. She wasn't chasing glory. She was a meticulous, serious scientist who cared deeply about accuracy and truth. In fact, she was cautious about publishing before she was absolutely sure, which is part of why Watson and Crick ended up racing ahead. But that mindset, that commitment to getting it right, is exactly why her data was so valuable. So the next time you hear about DNA, don't just think of Watson and Crick. Remember Rosalind Franklin, the woman who shined literal X-rays into the heart of life and revealed its hidden shape. Without her, the secret of life might have stayed secret for much longer. In a way, her story is bittersweet. She didn't live to see the full impact of her work or to receive the recognition she deserved. But her legacy is bigger than prizes or fame. Every time a genetic test saves a life, every time a DNA sequence solves a mystery, every time we unlock another layer of biology, Rosalind Franklin's fingerprints are there. She may not have been the one to shout the discovery from the rooftops, but she was the one who gave the world the evidence. And in science, that's what really matters.
Niels Stenson Steno, Fossils as Remains of Living Creatures. All right, let's rewind to the 1600s, a time when science was still sorting itself out from superstition, and the natural world was full of mysteries. People were fascinated by strange stones they dug out of the ground, seashells embedded in rock, fish-shaped impressions, or even what looked like giant tongues carved in stone. These objects were called tongue stones, or figured stones, and the common belief was they were just funny tricks of nature, maybe even sports of the earth. That's right. The idea that fossils were once part of living creatures, not widely accepted. To most people, it sounded absurd. And then came Niels Stenson, or as history remembers him, Steno. Steno was a Danish scientist born in 1638, and honestly, he was a bit of a Renaissance man. He studied anatomy, medicine, and natural philosophy. But his big leap into the world of fossils came from his knack for observation and a willingness to ask the obvious question, what if these tongue stones really were once shark teeth? Here's the story. Steno was working in Italy in the 1660s when he came across fossilized shark teeth.
People had been digging them up for centuries, but nobody could explain why they looked exactly like shark teeth. Some claimed they grew in the rocks. Others said they fell from the moon. Seriously. But Steno compared the fossilized teeth to the jaws of actual sharks he dissected, and the resemblance was undeniable. He made the bold claim, these weren't rocks pretending to look like teeth. They were actual teeth from once living sharks, preserved over time. This was revolutionary. It sounds obvious to us now, but back then it challenged deep-seated beliefs about nature, Earth's history, and even religious interpretations of the world. By suggesting fossils were remains of living things, Steno cracked open the door to the science of paleontology and laid the foundation for geology. But he didn't stop there. Steno also tackled the question, how do fossils end up inside rocks? His answer was brilliant and simple. He proposed that layers of rock, or strata, form over time as sediments settle from water or wind. Fossils get trapped in those layers, and as more layers build on top, they're buried and preserved. From this, he developed principles that every geology student still learns today. The principle of superposition. Younger layers of rock are deposited on top of older ones. The principle of original horizontality. Layers of sediment are originally laid down horizontally. The principle of lateral continuity. Layers extend horizontally until something cuts them off. These ideas sound straightforward, but they were groundbreaking. They allowed scientists to start reading Earth's history like a book, layer by layer. Suddenly, the planet wasn't just a static stage for human trauma. It was a dynamic system with a deep past, full of ancient creatures that once lived, died, and left their traces behind. Now, here's where Steno's story takes a fascinating twist. Despite his genius, he didn't spend his whole life doing science. In fact, after making these revolutionary contributions, he shifted paths completely. In the 1670s, he turned deeply toward religion, became a Catholic priest, and later a bishop. He stopped publishing scientific work altogether and spent his later years focused on theology and serving the church. Some people even see this as a loss to science. Imagine what more he could have discovered if he'd kept going. Still, what he did leave behind was enough to change everything. Before Steno, fossils were curiosities. After Steno, they became evidence, proof that Earth had a long, layered history, and that life had existed for eons before humans. His principles eventually guided geologists like James Hutton and Charles Lyell centuries later, and those in turn influenced Charles Darwin when he developed the theory of evolution. So you could argue that Steno's little insight about shark teeth set off a domino effect that reshaped all of science. And here's something poetic. In 1988, Steno was actually beatified by the Catholic Church, kind of like a step toward sainthood. So he's remembered both as a father of geology and as a man of faith. That dual legacy makes him a unique figure in history, bridging roads that often seem in conflict. Let's pause and appreciate just how radical his insight was for the time. Imagine being surrounded by people who think fossils just grow in rocks, and you say, nope, these are real, once-living animals. You'd be going against centuries of tradition. That takes courage, and it takes a mind that isn't satisfied with easy answers. And think of the impact today.
Our entire understanding of dinosaurs, ancient ecosystems, climate changes, and even the age of Earth rests on the foundation Stinon laid. Every time a paleontologist digs up a fossil and places it in the geological timeline, they're applying principles he wrote down in the 1600s. Not bad for a guy who just wanted to figure out why shark teeth were buried in the hills of Tuscany. So the next time you see a fossil in a museum, don't just think of dinosaurs or ancient seas. Think of Niels Stenson, the man who looked at a tungstone and had the audacity to say, "Hey, that's just a shark tooth," and in doing so helped us see the Earth not as static, but as a living history written in stone.
Henrietta Lacks, via her cells, the immortal HeLa cell line. Let's start with a question. If I told you one person's cells have helped test almost every vaccine, contributed to curing diseases, and even gone into space, would you believe me? Sounds like something out of science fiction, right? But it's true, and the person behind it was a woman named Henrietta Lacks. Henrietta wasn't a scientist. She wasn't a doctor. She was a 31-year-old African-American woman, a mother of 5, living in Baltimore in the early 1950s. She worked on a tobacco farm, lived a modest life, and had no idea that her cells would become one of the most important tools in medical history. Her story begins in 1951, when Henrietta went to Johns Hopkins Hospital, one of the only hospitals at the time that would treat Black patients. She was in pain, and doctors discovered she had an aggressive form of cervical cancer. While treating her, the doctors did something that was common in that era, but shocking by today's standards. They took a small sample of her tumor cells without asking for her permission. Now here's where the unbelievable part comes in. Normally, human cells don't survive long outside the body. Scientists had tried for years to grow human cells in the lab, but they always died after a few divisions. Henrietta's cells? They didn't die. They just kept dividing and dividing, doubling every 20 to 24 hours, stronger than any human cells scientists had ever seen. These cells became the first immortal human cell line, later named HeLa cells, from the first 2 letters of Henrietta Lacks's name. And once scientists realized what they had, the research world exploded. Think about all the medical breakthroughs you've heard of: the polio vaccine, cancer treatments, in vitro fertilization, HIV research, gene mapping, even COVID-19 vaccines. All of these and so many more have relied on HeLa cells. They've been shipped to labs all over the world, used in over 70,000 scientific studies, and even sent up in rockets to see how human cells behave in zero gravity. It's no exaggeration to say that if modern medicine had a secret weapon, it's Henrietta's cells. But here's the complicated, very human part of the story. Henrietta herself never knew. She passed away in 1951, the same year her cells were taken. Her family didn't know either, not for decades. Meanwhile, HeLa cells were everywhere, fueling science and even becoming part of a multi-billion-dollar biomedical industry. Companies were making money from them, but the Lacks family, Henrietta's children and grandchildren, weren't even told that her mother's cells were being used. When the family finally learned about it in the 1970s, it was a huge shock. Imagine finding out your mother's cells had become immortal, that parts of her were literally living in laboratories across the planet. Some family members felt proud, others felt exploited. They had to wrestle with questions of consent, privacy, and fairness that science had never fully addressed before. And this is why Henrietta Lacks's story is so powerful. It's not just about science, it's about ethics. Her cells gave the world so much, but her family had to fight for recognition and a voice in how they were used. It sparked debates about patient rights, medical consent, and who really owns biological material once it leaves your body. Eventually, things started to change. In 2013, the National Institutes of Health, NIH, reached an agreement with the Lacks family. Scientists could still use HeLa cells, but the family would have some say in how genetic information from those cells was shared. Today, Henrietta is finally recognized as a crucial figure in medical history. She's honored in books, museums, and even has a statue at the National Institutes of Health. But let's not lose sight of what makes this story so mind-blowing. Henrietta was an ordinary woman who never set foot in a research lab, yet her cells have saved millions of lives. Every time someone gets a vaccine, every time a new cancer drug is tested, every time doctors learn something new about human biology, a part of Henrietta is there. And here's something to think about. If her cells had been just like everyone else's, if they had died like normal, we might not have the vaccines, treatments, or genetic knowledge we take for granted today. The fact that her body produced this biological miracle, cells that refused to die, changed the course of medicine forever. So the next time you hear about a medical breakthrough, remember Henrietta Lacks. Remember that behind the microscopes and the petri dishes and the clinical trials, there was a real woman who went to the hospital for help and unknowingly gave the world a gift so extraordinary that it still echoes through every corner of science. Henrietta's story is a reminder that behind every great discovery, there's a human life, sometimes forgotten, sometimes overlooked, and that recognizing those lives is just as important as celebrating the science they made possible.
Lise Meitner co-discovered nuclear fission. Let me ask you something. When you think of nuclear energy, the stuff that powers entire cities, but also created the most destructive weapons ever built, whose name comes to mind? Most people would probably say Einstein, maybe Oppenheimer, or even Fermi. But there is a name that deserves to be shouted just as loudly, and it's one that history nearly buried. Lise Meitner. Born in 1878 in Vienna, Lise grew up at a time when women weren't exactly welcomed into the world of science. In fact, in Austria, girls weren't even allowed to go to university when she was young. But she was obsessed with physics, the invisible rules of how the universe worked, and she pushed her way in. By 1906, she had become only the second woman to earn a doctorate in physics at the University of Vienna. Fast forward a few years, and Lise moves to Berlin, where she starts working with chemist Otto Hahn. The two became a legendary scientific duo. Think brains and precision combined. Hahn handled the chemistry side, isolating substances, while Meitner brought the deep theoretical understanding of physics. They made discovery after discovery about radioactivity, becoming pioneers in nuclear science. Now, here's where the story gets really intense. In the 1930s, the world of physics was buzzing with talk about splitting atoms. Scientists knew the atom was made of a dense nucleus, but could that nucleus actually be broken apart? If so, what would happen? Nobody knew. Hahn and Meitner, along with their team, set out to investigate, but then politics crashed into science.
In 1938, Nazi Germany annexed Austria. Lise Meitner, who was Jewish, suddenly found herself in extreme danger. Despite her accomplishments, her position in Germany became impossible. With the help of friends, she fled the country, literally sneaking out on a train with only a small suitcase. She left behind her lab, her notes, and the scientific partnership she had built for decades. It was a heartbreaking exit. Otto Hahn stayed in Germany, continuing the experiments they had started together. Later that same year, Hahn's team bombarded uranium with neutrons and found something strange. Instead of producing heavier elements as expected, the uranium seemed to split into lighter elements, like barium. Hahn wrote to Meitner about it, confused. How could this be? Meitner, now in exile in Sweden, thought long and hard about the results. Walking in the snowy woods with her nephew, physicist Otto Frisch, she had a breakthrough. She realized that the uranium nucleus had literally split apart, a process she named fission. And here's the kicker. She calculated the energy released using Einstein's famous equation, E equals mc squared. The results were staggering. Splitting just one atom released a huge amount of energy. Think about that. In a snowy forest, without a lab, without equipment, she explained one of the most important scientific discoveries of the 20th century, nuclear fission, the principle behind both nuclear power and nuclear bombs. Here's where the story gets bittersweet. In 1944, Otto Hahn received the Nobel Prize in Chemistry for the discovery of nuclear fission. Lise Meitner? She wasn't even mentioned. The committee ignored her contributions, despite the fact that she had provided the theoretical explanation that made sense of Hahn's results. She had been erased from one of the greatest scientific breakthroughs of all time. But history doesn't stay silent forever. Over time, her role was finally recognized. Albert Einstein himself called her the German Marie Curie. Scientists later admitted the Nobel snub was one of the worst oversights in its history, and today she's honored in ways Hahn never was. Element 109 on the periodic table is named Meitnerium after her. Her personal story is just as remarkable as her scientific one. Unlike some of her contemporaries, Lise refused to work on the Manhattan Project, the U.S. program that developed the atomic bomb. Even though her discovery had opened the door, she wanted no part in weaponizing it. She called herself a physicist who would never participate in building a bomb. Instead, she spent her later years teaching, mentoring, and speaking out about science's responsibility to humanity. Let's pause for a moment and really appreciate what she did. Nuclear fission wasn't just a cool scientific curiosity. It changed the world. It gave us nuclear reactors, capable of producing vast amounts of clean energy. It also gave us the atomic bomb, capable of ending wars or ending the world. And at the heart of this double-edged sword was the mind of Lise Meitner, a woman who had to fight her way into science, flee her country, and then watch as others took credit for her brilliance. So the next time you hear about nuclear power plants or see documentaries about the atomic age, remember Lise Meitner. Remember the woman who stood in a snowy forest with a notebook and cracked the code of the atom. She wasn't just a scientist. She was proof that determination, insight, and courage can change the course of human history, even if the recognition comes decades too late.
Mary Anning discovered the first complete ichthyosaur and plesiosaur fossils. Let's start with an image. The southern coast of England in the early 1800s. Picture towering cliffs, salty sea spray, and a little girl with a basket in hand, clambering over rocks looking for curiosities. That girl was Mary Anning, and though she didn't know it at the time, she was about to change how humanity saw life on Earth. Mary was born in 1799 in the town of Lyme Regis, a spot now nicknamed the Jurassic Coast, because the cliffs are packed with fossils from the Jurassic period. But back then, fossils weren't scientific treasures. Most people thought they were odd decorations, maybe even weird accidents of nature. Scientists hadn't yet pieced together the story of extinct animals. Extinction itself was still a controversial idea. Mary's family was poor, and her father taught her to collect and sell fossils to tourists as a way to make money. These curios included ammonites, belemnites, and what locals called devil's fingers. For Mary, it started as survival. But she had a gift. She wasn't just collecting fossils, she was studying them, noticing details others overlooked. And then, at just 12 years old, Mary made her first world-changing find. In 1811, she and her brother Joseph uncovered the skull of something strange sticking out of the cliffs. Mary kept digging and eventually revealed the first complete skeleton of an ichthyosaur, a massive marine reptile that looked like a cross between a dolphin and a crocodile. Imagine being a kid and pulling a 17-foot sea monster out of the ground. At the time, the scientific community didn't even know what to make of it. Some thought it was a fish, others thought it was a crocodile. But slowly, the realization dawned. This was evidence of a whole group of creatures that once ruled the seas but no longer existed. Fossils weren't tricks of nature. They were the remains of real extinct animals. And Mary wasn't done. In 1823, she made another jaw-dropping discovery, the first complete skeleton of a plesiosaur, a long-necked marine reptile that looked like something out of mythology. With its tiny head, snake-like neck, and massive body, it was so strange that some scientists at first refused to believe it was real. They thought Mary had faked it by cobbling together different animals. But she hadn't. She had simply uncovered one of the most extraordinary creatures of the prehistoric world. Later, she also discovered a pterosaur, a flying reptile in Britain, as well as countless fish fossils, and the first evidence of what we now call coprolites, fossilized poop. Yes, she helped prove that even dino droppings had scientific value. But here's the thing about Mary's story. Even though her discoveries shook the foundations of natural history, she rarely got credit in her lifetime. She was a working-class woman in the 19th century. No formal education, no scientific society memberships, no fancy titles. Male scientists would often buy her fossils, study them, and publish papers without mentioning her name. One geologist even admitted she has not been given half the credit she deserves. And yet, word about Mary spread. People began to recognize her uncanny talent for finding and identifying fossils. Famous scientists like Charles Lyell and Richard Owen, the guy who later coined the word dinosaur, consulted her. Even the French naturalist Georges Cuvier, who was initially skeptical about the plesiosaur, eventually acknowledged her discovery as genuine. Mary Anning became a quiet legend, the woman combing the cliffs who kept pulling entire lost worlds out of stone. And despite living a life full of hardship, she never married, faced poverty constantly, and died young of breast cancer at 47, she carved her name into the story of science. Today, she's celebrated as one of the founders of paleontology. Let's think about how radical her work really was. Before Mary, fossils were mysterious trinkets. After Mary, they were undeniable proof that Earth was ancient and entire species had risen and fallen long before humans. Her finds helped lay the groundwork for Darwin's theory of evolution and transformed geology and biology into modern sciences. And here's a fun little detail. Remember the tongue twister, "She sells she-shells by the seashore"? Many historians believe it was inspired by Mary Anning, the fossil hunter of Lyme Regis. So next time you see a fossil in a museum, an ichthyosaur, a plesiosaur, or even a little ammonite, think of Mary Anning, the girl with a basket on the cliffs who taught the world that rocks could tell stories, that monsters once swam in our seas, and that science can come from the most unexpected places.
Galileo Galilei improved the telescope and discovered Jupiter's moons. Picture this. It's 1609 and you're in Italy. Rumors are spreading about a strange new device from the Netherlands, a tube with lenses that lets you see far-away things up close. Most people see it as a fun novelty, something for sailors or merchants. But for Galileo Galilei, a curious professor in Padua, it's the key to unlocking the secrets of the universe. Galileo didn't invent the telescope, but he improved it massively. The early versions could barely magnify 3 times. Galileo built one that magnified 20 times. Suddenly, mountains on the moon, countless stars in the sky, and even planets themselves were within reach. Imagine living your whole life believing the heavens were perfect and unchanging, only to look through a tube and see craters and scars on the moon. It was like peeking behind the curtain of the cosmos. Then came the discovery that changed everything. On January 7th, 1610, Galileo pointed his telescope at Jupiter. At first, he noticed 3 tiny stars near the planet. The next night, they had shifted. A few nights later, he saw 4, and they weren't behaving like stars at all. They were orbiting Jupiter. These would later be named the Galilean moons, Io, Europa, Ganymede, and Callisto. Why was this such a big deal? Well, at the time, the dominant belief was that everything in the universe revolved around the Earth. The Earth was supposed to be the center of all creation, immovable, perfect, central. But here was proof that at least 4 objects were not circling Earth, they were circling Jupiter. It was like Galileo had found a cosmic smoking gun. This discovery, along with his observations of Venus's phases and Saturn's rings, was the nail in the coffin for the old geocentric, Earth-centered model of the universe. Galileo had hard evidence that Copernicus's heliocentric theory, the idea that the Earth and planets revolve around the sun, was right. But science wasn't just about evidence back then. It was tangled with philosophy, politics, and religion. Galileo's findings didn't make everyone cheer. In fact, they caused an uproar. The Catholic Church, which held enormous influence, saw heliocentrism as a threat to scripture and tradition.
Some scholars mocked Galileo, saying the moons were illusions caused by his trick telescope. Others flat out refused to look through the telescope at all, claiming if God had meant for us to see these things, he would have made them visible to the naked eye. Galileo, never one to stay quiet, published his discoveries in Sidereus Nuncius, the Starry Messenger. He became famous and infamous almost overnight. He dedicated the moons to the powerful Medici family, calling them the Medicean stars, which was both a clever political move and a way to ensure his funding. But his defense of the heliocentric model got him into deeper and deeper conflict with church authorities. By 1633, things came to a head. Galileo was hauled before the Roman Inquisition, accused of heresy for supporting the sun-centered system. He was forced to recant publicly, saying the earth did not move. Legend has it that after muttering his confession, he whispered the defiant words, "And yet it moves." Whether that moment actually happened or not, it captures his spirit perfectly. Galileo spent the rest of his life under house arrest, forbidden from publishing his ideas. And yet, his discoveries could not be erased. The telescope had opened a new window on the universe, and no amount of denial could shut it. The moons of Jupiter were out there, plain as day, for anyone with a lens to see. Over time, Galileo's evidence spoke louder than any decree, and the heliocentric model became the foundation of modern astronomy. Think about the ripple effect here. Without Galileo, we might still see the universe as Earth-centered. His telescope showed us that the cosmos was vast, complex, and far beyond human imagination. His discoveries paved the way for Kepler's laws of planetary motion, Newton's laws of gravity, and eventually our understanding of galaxies, black holes, and the Big Bang. But here's something I love about Galileo's story. It's not just about science. It's about courage. He wasn't a rebel for rebellion's sake. He was a man who trusted his eyes, his reason, and the evidence, even when the world told him to shut up. He risked his reputation, his freedom, and his safety to defend the idea that the universe was bigger than we thought. And here's a fun twist. Today, those 4 little dots of light he discovered are some of the most fascinating places in the solar system. Europa may have an ocean under its icy crust that could harbor life. Io is the most volcanically active body we know. Ganymede is the largest moon in the solar system, bigger than Mercury. And Callisto is an ancient, cratered world that might one day host human outposts. Galileo couldn't have imagined all that, but he set the stage for it by simply looking through a tube and daring to believe what he saw. So the next time you glance at the night sky, remember Galileo Galilei, the man who turned a simple telescope into a revolution, discovered moons circling another planet, and forever changed how we see ourselves in the universe. He showed us that Earth is not the center of it all, but part of something far greater.
Louis Pasteur developed pasteurization and early vaccines. Let's start with something familiar. Picture a glass of milk, cold, fresh, creamy. You probably don't think twice before drinking it. But rewind to the 1800s, and that same glass of milk could easily have been crawling with bacteria, soured within hours, and even dangerous to drink. The man who changed that, who made milk safe, beer last longer, and also gave us some of the first vaccines, was Louis Pasteur. Born in France in 1822, Pasteur wasn't the kind of kid you'd expect to become a scientific giant. He wasn't a child prodigy like some of his peers. He was more into art than academics. But over time, he developed a passion for chemistry and a knack for careful observation. That knack would eventually lead him to discoveries that saved millions of lives. His first big contributions came from studying fermentation. Brewers and winemakers were constantly battling a problem. Sometimes their beer or wine would spoil, turning sour or tasting awful. The mystery baffled people. Was it just bad luck? A curse? Something in the air? Pasteur put the question under a microscope, literally. When he looked closely at fermenting liquids, he realized they were teeming with tiny organisms. And here's the key. He noticed that good fermentation, like turning grapes into wine, was caused by one kind of microbe, while spoilage was caused by another. That was a radical idea at the time. Most people believed in spontaneous generation, the belief that life could just appear from nowhere, like maggots spontaneously appearing in rotting meat. Pasteur showed that wasn't true. Life came from life, and microbes, invisible to the naked eye, were the culprits behind food spoilage and disease. To prove it, he did a now famous experiment with what's called a swan-necked flask. He boiled broth inside flasks with long curved necks that let air in but kept dust and microbes out. The broth stayed clear and unspoiled. But if the flask was tipped, letting microbes in, the broth spoiled. Boom! Spontaneous generation was debunked, and the germ theory of disease was born. Now here's where the everyday impact comes in. Pasteur realized that if heat could kill the microbes in his experiments, maybe heat could also prevent wine, beer, and milk from spoiling. He developed a process of gently heating liquids to kill harmful microbes without ruining the flavor. That process became known as pasteurization, and you still see it stamped on milk cartons today. Every safe sip of milk, every smooth glass of beer owes something to Pasteur's curiosity about why drinks spoiled. But Pasteur didn't stop at food. He wanted to tackle disease itself. At the time, deadly illnesses like anthrax and rabies seemed unstoppable. Farmers were losing entire herds of livestock to anthrax, and rabies was a death sentence for humans. Pasteur believed vaccines could stop them. Inspired by earlier work on smallpox vaccination, he started experimenting. Here's one of his boldest moments. In 1881, he organized a public demonstration for his anthrax vaccine. He took two groups of sheep, one vaccinated, the other not. He injected both groups with anthrax. The unvaccinated sheep died. The vaccinated ones lived. The crowd was stunned. It was undeniable proof that his vaccine worked. Farmers celebrated, and Pasteur's name spread across the world. Then came his most famous achievement, the rabies vaccine. Rabies was terrifying. Once symptoms started, it was almost always fatal. Pasteur worked tirelessly to weaken the virus in the lab, developing a vaccine that could train the immune system to fight it off.
In 1885, he faced his ultimate test. A young man named Joseph Meister had been bitten by a rabid dog. His family, desperate, begged Pasteur to help. Pasteur wasn't even a licensed physician, but he decided to try. He injected the boy with his experimental vaccine, and it worked. Joseph survived. That moment marked a turning point in medicine. Vaccines could save human lives. Pasteur's work didn't just help individuals, it transformed society. His discoveries laid the foundation for microbiology, sterilization, modern hygiene, and immunology. Think about it. Every time a surgeon sterilizes their tools, every time we wash our hands to avoid spreading germs, every vaccine that prevents a deadly outbreak, all of it traces back to Pasteur's germ theory. Of course, his career wasn't without struggle. Pasteur faced skepticism from other scientists who clung to old ideas. He was criticized for being bold, for rushing into applications, and for stealing the spotlight from collaborators. But his determination was unstoppable. He believed science wasn't just about knowledge, it was about improving human life. There's also something very human about Pasteur's story. He suffered a severe stroke in his 40s that left him partially paralyzed. Yet he kept working, kept experimenting, kept pushing the boundaries. He knew the stakes were bigger than his own comfort. And here's the beautiful irony. Pasteur started out studying spoiled wine and beer, and ended up saving humanity from spoiled health. His curiosity about why drinks went bad turned into insights that saved millions of lives from disease. Today, his legacy lives on not just in textbooks, but in everyday language. Pasteurization, Pasteur Institute. His name is literally embedded in the safety of our food and the foundation of our medicine. So the next time you grab a carton of milk from the fridge or roll up your sleeve for a vaccine, remember Louis Pasteur. He's the reason that milk won't make you sick. He's the reason vaccines protect you. He's the reason we understand that invisible microbes can cause disease, and that we can fight back. Pasteur didn't just change science. He changed life itself.
Gregor Mendel discovered genetics and inheritance laws. If I told you that the entire field of genetics, everything from eye color to DNA testing to genetically modified crops, started with a quiet monk growing peas in his garden, you might laugh. But it's true. The father of genetics, Gregor Mendel, wasn't a flashy scientist in a lab coat. He was a man in a monastery, carefully counting peas by the thousands, noticing patterns nobody else bothered to see. Gregor Mendel was born in 1822 in what's now the Czech Republic. He grew up in a poor farming family, but had a sharp mind and a love for learning. Eventually, he joined a monastery, partly because it gave him access to education. As an Augustinian friar, he studied philosophy, mathematics, physics, and eventually biology. But unlike many scientists of his time, Mendel wasn't chasing fame. He was curious. He wanted to understand how traits like height, color, or shape were passed down from one generation to the next. Now, you have to remember the context. In the mid-1800s, scientists didn't really understand heredity. Some thought traits just blended together like paint. Mix tall and short, you'd get medium. Others thought traits were sort of imprinted on offspring in mysterious ways. No one had cracked the code. Mendel decided to take a systematic approach
and his tool of choice was the pea plant. Why peas? Well, they're easy to grow, they reproduce quickly, and they have clear, visible traits. Some are tall, some short. Some produce yellow peas, some green. Some have smooth peas, some wrinkled. Perfect material for experiments. And Mendel wasn't casual about it. He was meticulous, almost obsessive. He cross-pollinated peas with paintbrushes, kept detailed notes, and carefully tracked each generation. He wasn't just gardening, he was conducting one of the first true scientific experiments in biology. Over years of work, Mendel gathered mountains of data. And here's what he noticed. Traits didn't blend. They followed predictable ratios. For example, when he crossed pure yellow peas with pure green peas, the first generation was all yellow. But when those plants were crossed again, suddenly green peas reappeared in the next generation, about 1 out of every 4. That's not random. That's a pattern. From these observations, Mendel proposed that traits are controlled by discrete factors, what we now call genes. Each parent passes down one factor for each trait, and those factors can be dominant or recessive. That's why a hidden trait, like green peas, can disappear in one generation and reappear in the next. Think about how revolutionary this was. Mendel basically cracked the fundamental rules of inheritance long before we even knew DNA existed. He figured out dominance, segregation, and independent assortment, principles that still form the backbone of genetics today, and he did it with nothing more than pea plants and math. But here's the twist. Almost nobody listened. Mendel published his findings in 1866 in a local scientific journal, but the scientific community at large ignored him. Some thought his results were too neat to be real. Others simply didn't grasp the significance. Darwin's On the Origin of Evolution had come out just a few years earlier, and the world was buzzing about evolution. If only Darwin had seen Mendel's work, the theory of evolution and genetics might have been linked decades earlier, but they never connected. So Mendel went back to his monastery duties. He became abbot, got busy with administrative work, and slowly his experiments faded into obscurity. He died in 1884, never knowing that his pea garden would change the world. It wasn't until around 1900, more than 30 years later, that 3 different scientists, Hugo de Vries, Karl Korrentz, and Erich von Tschermak, independently rediscovered Mendel's paper. Suddenly, the scientific community realized he had solved the puzzle of inheritance decades earlier. From then on, Mendel was recognized as the father of genetics. And the impact? Monumental. His principles paved the way for understanding DNA, chromosomes, mutations, genetic diseases, and modern biotechnology. What I love about Mendel's story is how relatable it is. He wasn't a wealthy scientist with a fancy lab. He was a monk working patiently in a garden, doing something that seemed simple, but looking at it in a new way. He didn't need cutting-edge equipment, just curiosity, patience, and math. And there's something poetic about it, too. Peas, humble little plants, became the key to unlocking the code of life. It's almost like nature was whispering its secrets in the quiet of that monastery garden, and Mendel was the one who listened. So the next time you eat peas,
Or think about how you got your mom's eyes but your dad's laugh. Remember Gregor Mendel. He showed us that heredity isn't random, it's patterned. Traits are passed down through invisible rules. And even though the world ignored him at first, his pea plants ended up shaping the future of biology. Mendel proved that science isn't always about fame or recognition. Sometimes it's about patience, persistence, and counting peas until the truth reveals itself.
Antony van Leeuwenhoek built microscopes and discovered microorganisms. Let's take a step back and imagine the 1600s. People believed the world was basically what you could see with your own eyes. Sure, there were telescopes to look at the stars, but when it came to the small stuff, water, food, the human body, it seemed simple enough. If you couldn't see it, it didn't exist, right? Well, then along came Antony van Leeuwenhoek, a Dutch tradesman who, get this, wasn't even a professional scientist. He was a fabric seller in Delft, Netherlands. That's right, not a professor, not a doctor, not a chemist. Just a curious man with a knack for tinkering. And it was this curiosity that opened the door to a world no human had ever seen before, the world of microorganisms. So how does a fabric seller end up changing science forever? It started with his trade. Selling fabrics meant needing to inspect the fine details of cloth, the threads, the weave, the texture. For that, Leeuwenhoek started experimenting with magnifying lenses. But instead of being satisfied with the simple magnifiers most merchants used, he pushed the technology further. He ground and polished tiny glass lenses with incredible precision, creating simple microscopes that were far more powerful than anything available at the time. While other microscopes of his era might magnify 20, 30 times, Leeuwenhoek's homemade devices could reach over 200 times magnification. That might not sound like much compared to modern microscopes, but in the 1600s, it was like strapping on a pair of glasses that suddenly revealed a hidden dimension of reality. And what he saw through those lenses blew his mind. He looked at drops of pond water and saw tiny creatures darting around. He examined plaque scraped from his own teeth and found wriggling little animalcules. That's the word he used. It basically means tiny animals. He studied blood and saw red blood cells, the first human to ever lay eyes on them. He studied sperm cells, muscle fibers, bacteria, and even tiny capillaries carrying blood. Everywhere he turned his microscope, he found life. Life so small, nobody had imagined it was there. Think about how earth-shattering that was. People had no concept of germs, bacteria, or microscopic life. Diseases were blamed on bad air, miasma, curses, or imbalances in the body's humors. And here was Leeuwenhoek, a cloth merchant, discovering that the world was absolutely swarming with invisible life forms. At first, scientists didn't even believe him. His claims sounded ridiculous. Little creatures living in a drop of water? Tiny organisms in our mouths? It sounded like fantasy. But Leeuwenhoek was stubborn. He carefully documented his observations, wrote letters, and sent them to the Royal Society of London. To prove he wasn't making it up, he even invited skeptics to Delft to look through his lenses themselves.
And sure enough, when they peered into his microscopes, they saw the same wriggling creatures he described. Over time, Leeuwenhoek's reputation grew. He became known as the father of microbiology, even though he had no formal training. He wasn't theorizing about what he saw. He was simply observing, documenting, and sharing. And that was enough to spark a revolution. His discoveries laid the foundation for germ theory, though it would take another 2 centuries for scientists like Pasteur and Koch to connect microorganisms with disease. Still, without Leeuwenhoek, we wouldn't even have known microbes existed in the first place. But what makes his story even more inspiring is how personal it was. He built more than 500 microscopes in his lifetime, each carefully grafted by hand. He didn't mass-produce them or chase fame. He was just fascinated by what he saw. He once wrote, "I've taken no notice of those who have said that what I have related is not true, but I continue steadfastly to investigate." That's pure scientific curiosity in action. And he kept discovering right up until the end of his life. In fact, some of his final observations were of bacteria living in his own gut during an illness. Even as he was dying, he was peering into his lenses, still learning, still curious. Here's the part that always amazes me. Leeuwenhoek basically revealed an entire universe that had been sitting right under humanity's nose, or rather on it, in it, and around it, the whole time. Without him, we might still be clueless about the microscopic world. Modern medicine, biology, sanitation, and public health all trace their roots back to his little glass lenses. So the next time you wash your hands, drink clean water, or hear about good bacteria in yogurt, thank Antony van Leeuwenhoek. He showed us that the world isn't just what we can see. It's teeming with invisible life, a hidden kingdom that shapes our health, our planet, and our very existence. And to think all of that came from a fabric seller in Delft, who decided his magnifying glass wasn't strong enough, so he built a better one. Curiosity changed the world.
Ada Lovelace wrote the first computer algorithm for Charles Babbage's machine. If I told you the first person to write a computer program lived in the early 1800s, before electricity, before typewriters, before radios, you'd probably think I was joking. But that's exactly the story of Ada Lovelace. She imagined a digital future long before anyone else could. Ada was born in 1815 in London, the daughter of the famous poet Lord Byron and Lady Anne Isabella Milbank. Byron, being Byron, wasn't exactly the family man type. He abandoned Ada and her mother when she was just a baby. Her mother, bitter about her ex-husband's wild, emotional life, pushed Ada towards something very different, math and science. In a way, it was her way of saying, you won't end up like your poet father. And Ada did love numbers. She was fascinated by mathematics from a young age. But she wasn't just logical. She also had her father's imaginative streak. That combination, logic and creativity, would become her superpower. Fast forward to her late teens, and Ada meets Charles Babbage, a mathematician and inventor. Babbage was a bit of a dreamer himself. He had this ambitious idea to build a mechanical calculating machine he called the analytical engine. Think of it as the ancestor of the modern computer. It had parts that sound suspiciously familiar today. A store, like a memory, a mill, like a processor, and the ability to use punched cards, kind of like early programming. But here's the thing. Babbage was great at designing the hardware, but not so great at explaining what it could do. That's where Ada came in. She was captivated by his invention and started studying it in depth. In 1842, an Italian mathematician wrote a paper about Babbage's analytical engine.
Ada translated it from French into English, but she didn't stop there. She added her own notes. And when I say notes, I don't mean a few comments in the margins. Her notes were 3 times longer than the original paper. Inside those notes was something groundbreaking. Ada wrote a step-by-step method for the machine to calculate Bernoulli numbers. If that sounds technical, here's the simple version. She basically wrote the first algorithm ever intended to be executed by a machine. That's right, Ada Lovelace was programming before computers even existed. But what makes Ada even more remarkable is the way she thought about the machine. Most people, including Babbage himself, saw it as just a fancy calculator, useful for crunching numbers faster. Ada, on the other hand, saw its true potential. She wrote that the analytical engine could do more than math. If numbers could represent things like sounds or letters, then the machine could compose music, write text, or create art. Read that again. In the 1840s, Ada Lovelace predicted that machines could one day generate music, images, and words, basically describing modern computers, creative software, and even artificial intelligence. That's mind-blowing foresight. Of course, the world didn't quite catch on. Babbage's analytical engine was never fully built in his lifetime. The technology just wasn't there yet. And Ada herself didn't live to see her vision take root. She died tragically young, at 36, from uterine cancer. For decades, her contributions were overshadowed by Babbage's designs. But history has a way of catching up. In the 20th century, when computers finally became a reality, people rediscovered Ada's notes. That algorithm she wrote for the analytical engine, it was recognized as the first computer program in history. Suddenly, Ada wasn't just a mathematician with a good imagination. She was a pioneer of computer science. And here's a cool bit of legacy. In the 1970s, the U.S. Department of Defense named a new programming language Ada in her honor. Today, Ada Lovelace is celebrated every year on Ada Lovelace Day, which highlights women in STEM. But beyond the titles and honors, I think what makes Ada's story so compelling is her mindset. She had this rare ability to combine cold, hard logic with poetic imagination. She didn't just see a machine, she saw possibilities. She envisioned a world where technology wasn't just about numbers, but about creativity, communication, and art. That's basically the world we live in now, where computers help us make music, design, tell stories, and even have conversations like this one. So next time you sit down at your laptop, open an app, or even watch a video online, remember Ada Lovelace. She was the first to dream that a machine could think beyond arithmetic. A dreamer, a mathematician, and the world's first computer programmer, all rolled into one.
Archimedes discovered principles of buoyancy, levers, and war machines. Let's roll the clock back over 2,000 years to ancient Greece. Picture the bustling city of Syracuse, a wealthy hub on the island of Sicily. It's here that one of history's greatest thinkers was born, Archimedes. If there's one name from ancient science that almost everyone has heard, it's his. But behind the myths and the catchphrases lies a man who was both a brilliant scientist and a bit of an eccentric genius. Archimedes lived in the 3rd century BCE, and he wasn't just dabbling in one field, he was everywhere. Mathematics, physics, engineering, astronomy, you name it, he touched it. What makes him fascinating is how practical his discoveries were. He wasn't just sitting around thinking about abstract numbers, though he loved that too. He was building things, solving real-world problems, and sometimes even inventing weapons. Let's start with one of his most famous contributions, buoyancy. You've probably heard the Eureka story. The king of Syracuse, Hiero II, suspected that a goldsmith had cheated him by mixing silver into his supposedly pure gold crown. He asked Archimedes to figure it out, but without damaging the crown. Not an easy task. The story goes that Archimedes was puzzling over it while taking a bath. When he lowered himself into the water, he noticed the water level rise. Suddenly, it clicked. The amount of water displaced was equal to the volume of his body. He realized he could use the same principle to test the crown. If the crown displaced more water than an equal weight of pure gold, it wasn't pure. Supposedly, Archimedes was so excited he leapt out of the bath and ran naked through the streets shouting "Eureka!" meaning, "I've found it." Now, whether the story happened exactly like that, we don't know. But the principle of buoyancy, that an object in fluid experiences an upward force equal to the weight of the fluid it displaces, is real and still used today. It explains why ships float, submarines dive, and hot air balloons rise. One bath time realization, and he gave us the foundation of fluid mechanics. But Archimedes wasn't done. He also gave us the principle of the lever. You know how a seesaw lets a small child lift a heavier one if they sit farther out? That's a lever in action. Archimedes studied how levers worked and explained that the farther the distance from the pivot point, the fulcrum, the greater the force you can apply. That's why he famously said, "Give me a place to stand and I will move the earth." It sounds dramatic, but it's mathematically true. With the right lever and enough distance, you could lift anything. Beyond principles, Archimedes loved building gadgets. He invented the Archimedes screw, a device for raising water that's still in use today in irrigation systems. Imagine a giant screw inside a cylinder. As you turn it, water lifts upward. Simple, clever, effective. Farmers thousands of years later are still grateful for that one. And then there's the part of Archimedes' life that feels like it came out of an action movie, his war machines. Syracuse was often caught up in conflict, and Archimedes turned his genius toward defending his city. He designed giant catapults, claw-like cranes that could lift enemy ships out of the water, and even a legendary death ray that supposedly used mirrors to set Roman ships on fire by focusing sunlight. Historians debate whether the death ray was real or just a later myth, but the fact that people even believed he could build one shows how legendary his reputation was. Archimedes wasn't just an engineer and inventor, though. He was a mathematician who loved tackling problems that seemed impossible. He figured out how to approximate pi with remarkable accuracy. He studied areas, volumes, and surfaces long before calculus was invented. He came up with ingenious ways to calculate things like the volume of a sphere or the area under a curve, methods that wouldn't be formalized until over 1,000 years later. But here's the thing about Archimedes. For all his brilliance, he was also very human. The stories about him often describe him as so absorbed in his work that he forgot about the world around him. He'd draw diagrams in the sand, mutter calculations, and ignore everything else. Even during the Roman conquest of Syracuse, the legend goes that he was killed because he was too busy drawing geometric figures in the dirt to pay attention. His death was tragic, but his legacy is enormous.
Archimedes showed that science isn't just abstract knowledge, it's something you can apply to real problems, whether it's building machines, solving puzzles, or defending your city. His discoveries in physics laid the foundation of mechanics. His mathematics inspired future generations. His inventions, both practical and fantastical, made him a legend. And here's the fun part. So many things we take for granted today go back to him. Every time you use a lever, float on water, calculate buoyancy for a ship, or even use simple pulleys and screws, that's Archimedes' fingerprints on history. So the next time you sit on a seesaw, watch a ship float, or hear the word eureka, remember Archimedes. He wasn't just a thinker. He was a doer, a problem solver, and one of the greatest scientific minds the world has ever seen. 2,000 years later, his principles are still holding up. That's the mark of true genius.
Benjamin Franklin proved electricity in lightning with a kite experiment. All right, let's set the scene. It's the mid-1700s. Electricity is this mysterious force that people are only beginning to play with. Scientists across Europe are rubbing amber with cloth, seeing sparks jump, and messing around with early electrical machines that produce static charges. It's a parlor trick more than anything else. Fun to watch, but no one really knows what it is. Then comes Benjamin Franklin, a man who wasn't even a trained scientist, but had one of the most curious minds in history. Now, Franklin is better known to most people as one of America's founding fathers. You know, the guy on the $100 bill, diplomat, politician, writer. But he was also a full-on science geek. He loved experiments, especially with electricity. He gave us terms we still use today, like battery, conductor, positive charge, negative charge, all Franklin's words. Not bad for someone who never had a formal degree. But the thing that made Franklin legendary was his obsession with figuring out whether lightning, that terrifying crack in the sky, was just a giant form of electricity. Today, it sounds obvious, but back then, this was a radical idea. Lightning seemed like something divine, a punishment from the gods. People lit candles in storms, prayed for safety, and stayed inside. Franklin thought, wait, what if it's just nature's electricity on a bigger scale? So he decided to test it. And this is where we get the famous kite experiment. The story most people know is simple. Franklin tied a key to a kite string, flew it in a thunderstorm, and when lightning struck the kite, electricity traveled down the string into the key and zapped him, proving lightning and electricity were the same thing. Sounds epic, right? Like some kind of superhero origin story. But here's the twist. That's not quite how it really happened. The full truth is a bit different, but no less fascinating. Franklin didn't actually get struck by lightning. If he had, he'd be a crispy piece of history, not a founding father. Instead, what happened is that the kite was up in the stormy air. The damp string started conducting electricity from the storm clouds. Franklin moved his hand close to the key and a spark jumped. That little spark was the aha moment. He had connected the dots.
Lightning was indeed electricity, just on a massive scale. It was brilliant because it was simple. Franklin didn't invent fancy instruments or machines for this. He used a kite, a key, and his own curiosity. Imagine risking your life in a thunderstorm just to prove a hunch. Most of us won't even walk outside without an umbrella if it looks like rain. Franklin was out there flying kites under storm clouds. And here's where it gets even more interesting. Franklin wasn't just doing this for the thrill. He immediately thought about practical uses. If lightning was electricity, maybe it could be controlled, maybe even prevented from causing damage. So he invented the lightning rod. That's the metal rod you see on top of tall buildings, churches, or barns. It safely channels lightning strikes into the ground instead of letting them burn down the structure. Think about how revolutionary that was. Before lightning rods, fires from lightning were devastating. Entire cities could go up in flames. Franklin's invention saved lives, buildings, and changed how humans interacted with nature's fury. And guess what? We still use lightning rods today. Over 250 years later, his idea hasn't needed an upgrade. But let's not skip over the personal side of this story. Franklin was known for his humor, and he later joked about the experiment, almost downplaying it like it wasn't a big deal. In truth, it was risky. Several other scientists in Europe who tried to replicate the kite experiment actually died. That's how dangerous it was. Franklin just got lucky. Or maybe he was cautious enough to avoid direct strikes. Either way, the fact that he walked away alive made him a legend. Now, beyond the kite experiment, Franklin's work with electricity had ripple effects across science. He helped establish the idea of charges, introduced the concept of conservation of charge, that electricity doesn't disappear, it just moves around, and gave later scientists a framework to build on. Without Franklin, the work of people like Michael Faraday or James Clerk Maxwell might have been delayed. And let's not forget, Franklin wasn't a full-time scientist. He was running printing presses, writing essays, engaging in politics, and later helping to shape a new nation. He's the kind of person that makes you feel lazy just reading about him. While we're struggling to finish a to-do list, Franklin was flying kites in thunderstorms, inventing bifocal glasses, founding libraries, and drafting constitutions. But the kite experiment stands out because it's the perfect mix of simplicity, danger, and brilliance. It's one of those stories that stick in your head forever. You can picture him, gray hair, string in hand, storm clouds overhead, lightning flashing, and that little spark that changed the world. To this day, when people talk about scientific curiosity, Franklin's kite is one of the first examples that comes up. It's the ultimate image of a curious human saying, "I wonder what would happen if," and then actually finding out, no matter the risk. So next time you see lightning rip across the sky, remember Franklin. Remember that at one point in history, humans thought lightning was untouchable, a weapon of the gods. And then one curious man with a kite and a key proved it was just another piece of nature's puzzle, one we could understand and even use to protect ourselves. That's Benjamin Franklin, the man who literally pulled electricity out of the sky.
James Clerk Maxwell formulated electromagnetic field theory. When we talk about the big three in physics, most people think of Newton, Einstein, and maybe Galileo. But ask a physicist, and they'll almost always slip in James Clerk Maxwell as part of that elite club. Why? Because Maxwell basically united electricity, magnetism, and light into one elegant theory. And that changed how we see the universe forever. So, who was this guy? Maxwell was born in 1831 in Scotland. From a young age, he showed that he wasn't your average kid. While other children were learning to read, Maxwell was already obsessed with patterns in the world around him. He'd trace shapes, draw diagrams, and ask way too advanced questions about how things worked. His mom encouraged his curiosity, but after she passed away, it was mostly his own relentless drive that kept him learning. By his teenage years, he was already presenting papers to scientific societies. Imagine being that nerdy 14-year-old who walks into a room of professors and says, "Actually, I've got something to share." That was Maxwell. Fast forward a bit, and Maxwell dives into one of the hottest scientific puzzles of his time, electricity and magnetism. Scientists already knew a bit about both. Michael Faraday, for example, had shown that electricity and magnetism were connected. Moving a magnet could generate an electric current, and electricity could create magnetic fields. But while Faraday was a hands-on experimenter who spoke in terms of lines of force, Maxwell was a mathematician. He wanted equations. He wanted a theory that tied everything together. And wow, did he deliver! Maxwell formulated a set of equations. Today, we call them Maxwell's equations that described how electric and magnetic fields interact. If that sounds abstract, let's break it down. His equations basically said, electric charges create electric fields. Moving charges, currents, create magnetic fields. Changing magnetic fields create electric fields. Changing electric fields create magnetic fields. Now, take a second with that last one. A changing electric field creates a magnetic field, which in turn can create another electric field, and so on. What does that mean? It means you can have a self-sustaining wave, an electromagnetic wave, traveling through space. And here's the mic drop moment. Maxwell calculated the speed of these waves. Guess what number popped out? About 300,000 kilometers per second, the speed of light. That's when Maxwell realized something jaw-dropping. Light itself is an electromagnetic wave. Suddenly, light wasn't some mystical property or a particle bouncing around. It was literally rippling electric and magnetic fields traveling through space. In one stroke, he united optics, the study of light, electricity, and magnetism into a single theory. Think about how huge that was. Before Maxwell, these were separate branches of science. After Maxwell, they were all part of one elegant framework, electromagnetism. It's hard to overstate how revolutionary this was. Maxwell's work paved the way for the entire modern world. Radio, television, Wi-Fi, X-rays, microwaves, cell phones, all of it relies on electromagnetic waves. Heinrich Hertz, who later confirmed electromagnetic waves experimentally, literally said, "It's just as Maxwell predicted." Guglielmo Marconi built radio on the back of Maxwell's theory. Einstein himself called Maxwell's work the most profound and the most fruitful in physics since Newton. But Maxwell wasn't just about heavy equations. He had a playful side too. He loved poetry, made jokes, and even wrote humorous verses about science. He also tackled problems outside of electromagnetism. He studied color vision and explained how the human eye perceives colors through 3 types of receptors. In fact, the very first color photograph ever made, a tartan ribbon, was produced thanks to Maxwell's work on color theory. So the next time you snap a photo on your phone, remember that Maxwell had a hand in that too.
Despite his brilliance, Maxwell's life was tragically short. He died of stomach cancer at just 48 years old, the same disease that had taken his mother. But in those short years, he transformed physics. And here's the thing I love most about Maxwell's story. He wasn't the loudest, flashiest scientist. He wasn't out there shocking himself like Benjamin Franklin or yelling Eureka like Archimedes. He was quiet, thoughtful, and deeply mathematical. Yet his equations whisper the secrets of the universe, secrets that power our entire technological civilization today. When you scroll through social media on Wi-Fi, listen to the radio, heat food in a microwave, or look at the stars with the telescope, you're living in Maxwell's world. His equations are humming behind the scenes, invisible but essential. So even if you don't recognize his face on a banknote or hear his name thrown around in everyday conversation, Maxwell deserves to be remembered as one of the true giants of science. He didn't just discover a new piece of the puzzle. He connected the puzzle pieces into a single picture and said, "Look, this is how the universe works." That's James Clerk Maxwell, the man who saw light as electricity and magnetism dancing across the cosmos.
Hippocrates founded the practice of clinical medicine, Hippocratic Oath. Let's take a trip way back in time, about 2,400 years ago, to ancient Greece. Picture it. Temples dedicated to healing gods, priests offering sacrifices, and people believing that illnesses came from curses or the wrath of the divine. If you had a fever or a cough, folks thought you'd made some god angry. That's the world Hippocrates was born into. And yet, this one man completely flipped the script on how we understand medicine. Hippocrates, often called the father of medicine, lived around 460 to 370 BCE. You've probably heard his name, especially in the phrase Hippocratic Oath. That's the ethical code doctors still echo today, where they promise to treat patients with care and do no harm. But Hippocrates wasn't just about pledges and oaths. He revolutionized how people thought about sickness itself. Before Hippocrates, medicine was wrapped up in religion and superstition. If someone had epilepsy, people thought they were possessed by demons. If a child had a fever, maybe they'd blame an angry ancestor or some mystical force. But Hippocrates came in and said, "Hold on, maybe it's not the gods at all. Maybe diseases come from natural causes." That was a radical idea for the time. Instead of blaming spirits, Hippocrates observed symptoms carefully. He watched how illnesses developed, how they changed over time, and how different environments affected people's health. He encouraged physicians to keep notes, detailed records of their patients' conditions, diets, and recoveries. Basically, he introduced the idea of clinical observation, studying the patient instead of guessing based on superstition. Now, one of the key ideas associated with Hippocrates is the theory of the four humors. This might sound a little weird today, but it was groundbreaking back then. He believed the human body was governed by four main fluids: blood, phlegm, yellow bile, and black bile. Health, he said, was about keeping these in balance. If someone was sick, it meant one of the humors was out of whack. For example, too much black bile, you'd be melancholic. Too much yellow bile, you'd be fiery and feverish. Now, we know today that the four humors aren't real. They're not what makes us healthy or sick.
But the idea of balance and natural causes of disease was revolutionary. It was the first time someone suggested that the body works according to rules of nature, not magic. That set the stage for modern medical science. And here's another big thing Hippocrates emphasized: the importance of lifestyle in health. He believed diet, exercise, and environment played huge roles in keeping people well. Sound familiar? That's exactly what doctors still say today. Eat balanced meals, move your body, avoid unhealthy habits. Hippocrates might not have known about vitamins or germs, but he understood that how you live shapes how you feel. The Hippocratic school, where he and his students practiced, became a place where this kind of thinking thrived. They wrote down their knowledge in what's now known as the Hippocratic Corpus, a collection of about 60 medical works. These texts covered everything from how to set a broken bone to how to diagnose pneumonia by listening to a patient's chest. Even though not all of them were written directly by Hippocrates himself, they carried his spirit of rational, careful medicine. And of course, we can't talk about Hippocrates without mentioning the Hippocratic Oath. It's probably one of the most famous legacies in medicine. In its original form, it bound doctors to ethical principles. Don't exploit patients. Don't give deadly poisons. Don't abuse your power. Over the centuries, the oath has been updated and modernized, but the core idea remains. Medicine isn't just about knowledge. It's about responsibility. Doctors aren't just technicians. They're caretakers of human life. Now, was Hippocrates perfect? Not at all. Remember, he didn't know about bacteria, viruses, or DNA. He couldn't explain why infections spread, or why some diseases hit certain people harder than others. Some of his treatments, like bloodletting, were based on humoral theory and don't hold up today. But the mindset he introduced, that illness has natural explanations and should be studied systematically, was revolutionary. Here's a funny little twist. For centuries after his death, Hippocrates became almost legendary. People in the Roman Empire, in medieval Europe, and even in the Islamic Golden Age referred back to his teachings. His name became synonymous with doctor. Even today, when someone calls a doctor Hippocratic, it means they're practicing medicine with an ethical, observational, and patient-centered approach. So why should we care about Hippocrates now, 2,400 years later? Because every time you go to the doctor and they check your symptoms carefully, instead of waving incense and chanting, you're living in Hippocrates' legacy. Every time a medical student swears an oath to put patients first, that's Hippocrates echoing through history. And every time someone reminds you to eat well and stay active to prevent disease, that's the father of medicine whispering advice from the ancient past. Hippocrates took healing out of the temple and put it into the clinic. He replaced superstition with observation. He made medicine not about appeasing gods, but about understanding humans. And that, more than anything else, is why he's remembered not just as a doctor, but as a founder of modern science itself. That's Hippocrates, the man who helped medicine grow up.
Antoine Lavoisier discovered the law of conservation of mass in chemistry. Let's head back to 18th century France,
a time of powdered wigs, candlelit laboratories, and revolutions brewing in the streets. In the middle of it all was a man named Antoine Lavoisier, whose curiosity and meticulous experiments transformed alchemy into what we now call chemistry. If Hippocrates helped medicine grow up, Lavoisier did the same for chemistry. Here's the thing. Before Lavoisier, chemistry wasn't really a science the way we think of it today. It was closer to alchemy, a mix of mystical ideas, guesswork, and a lot of smoke. People still believed in things like phlogiston theory, which claimed that all flammable materials contained the mysterious substance called phlogiston that escaped during burning. It sounds bizarre now, but back then it was the mainstream explanation for combustion. Lavoisier wasn't buying it. He was methodical. Instead of wild speculation, he used careful measurement and controlled experiments. And that's where his most famous idea came in, the law of conservation of mass. In simple terms, he proved that matter isn't created or destroyed in a chemical reaction. The mass of what you start with equals the mass of what you end with. That might sound obvious to us now, but back then it was revolutionary. People thought burning wood made the mass disappear into smoke. But Lavoisier showed that if you captured all the gases released, the mass stayed the same. Nothing was vanishing into thin air. It was just changing form. Picture Lavoisier in his lab, carefully weighing substances before and after reactions using one of the most precise balances of his time. If he burned sulfur or phosphorus, he made sure to collect the gases released. Every time, the math worked out. The numbers proved it. Matter didn't just vanish, it transformed. This principle became the bedrock of modern chemistry. But Lavoisier didn't stop there. He gave chemistry a whole new language. Before him, chemical names were confusing, often based on random traditions. He helped standardize names for elements and compounds, creating a systematic nomenclature. Thanks to him, we talk about oxygen, hydrogen, and carbon dioxide instead of vague terms like dephlogisticated air. His clarity turned a messy field into a proper science. Speaking of oxygen, that's another major contribution. Lavoisier helped identify and name it, showing that combustion and respiration were actually reactions involving oxygen. He worked with his wife, Marie Anne, who was not only his partner in life, but also in science. She translated English papers for him, illustrated his experiments, and even hosted salons where the brightest minds of Paris debated new discoveries. She was crucial in spreading his ideas. Lavoisier's insights extended beyond the lab, too. He applied his analytical mind to public service, studying agriculture, taxation, and even gunpowder production. In fact, his improvements to gunpowder made France's military stronger, which makes what happened to him later even more ironic. Because here's the tragic twist. Lavoisier lived during the French Revolution, and while his science was groundbreaking, his career outside the lab got him into serious trouble. He was a tax collector for the government, part of the very system the revolutionaries despised. No matter how brilliant he was in science, that role painted the target on his back. In 1794, during the height of the Reign of Terror, Lavoisier was arrested and put on trial. Despite pleas from fellow scientists who begged for his release, arguing that his work was too important to cut short,
he was sentenced to death. On May 8, 1794, Lavoisier was executed by guillotine at the age of just 50. There's a famous line attributed to mathematician Louis Lagrange after Lavoisier's death. It took them only an instant to cut off that head, but 100 years may not suffice to produce another like it. It's one of the most haunting tributes in the history of science. And yet, even in death, Lavoisier's ideas endured. The law of conservation of mass became a cornerstone of chemistry and physics. Later, Einstein expanded on it with his theory of relativity, showing that mass and energy are interchangeable. E equals mc squared. But without Lavoisier's groundwork, we might never have gotten there. So why should we remember Lavoisier today? Because every time you balance a chemical equation, every time you cook food, burn fuel, or even breathe in oxygen, you're living in a world shaped by his discoveries. He taught us that matter doesn't disappear, it transforms. That idea is so basic, so foundational, that it's hard to imagine science without it. And maybe just as important, Lavoisier showed what science could look like when it's based on precision, clarity, and careful measurement instead of guesswork and mystical theories. He dragged chemistry out of the Dark Ages and gave it structure. So the next time you see smoke rise from a fire, don't think of it as something vanishing. Think of Lavoisier, the man who weighed the world and taught us that mass is forever. That's Antoine Lavoisier, the man who weighed the world and taught us that mass is forever.
Carl Wilhelm Scheele discovered oxygen before Priestley, but unpublished. When we think about the discovery of oxygen, most people immediately name Joseph Priestley or Antoine Lavoisier. But tucked in history's shadow is Carl Wilhelm Scheele, a quiet Swedish chemist who actually discovered oxygen first. The catch? He didn't publish his results in time, and history almost forgot him. His story is one of genius, bad timing, and a little bit of tragedy. Scheele was born in 1742 in Stralsund, which was part of Sweden at the time. He didn't come from a rich or powerful family. He was just an apprentice in a pharmacy. That's where he fell in love with chemistry. Imagine him surrounded by jars of strange powders, herbs, and liquids, always curious about what happened when you mixed them together. He had no fancy laboratory, no big university backing him, just his curiosity and access to chemicals. And oh boy, did he make use of it. Scheele had a knack for experimenting. While many scientists of his time relied on theory or secondhand reports, he rolled up his sleeves and tested things himself. He heated, distilled, and mixed substances endlessly, jotting down results in meticulous notes. He wasn't afraid to try unusual combinations, and that's where many of his discoveries came from. Here's the big one: oxygen. Around 1771, Scheele was heating compounds like manganese dioxide and various nitrates and noticing they released a gas. This gas, unlike regular air, made candles burn brighter and living creatures more active. He called it fire air because it seemed to feed flames. Sound familiar? Yep, that was oxygen. Here's the twist. Even though Scheele discovered oxygen years before Priestley, who did so in 1774, Scheele didn't publish his findings right away. He wrote about it in a manuscript he called Treatise on Air and Fire, but it wasn't printed until 1777.
By then, Priestley and Lavoisier were already making names for themselves. History gave them the spotlight, while Scheele was left as a footnote. It wasn't just oxygen, though. Scheele discovered or co-discovered an astonishing list of substances: chlorine, glycerol, hydrogen cyanide, barium, molybdenum, tungsten, and more. His notebooks read like a greatest hits list of modern chemistry. Some scientists have joked that Scheele practically discovered half the periodic table before anyone else even knew it existed. But here's the heartbreaking part. Scheele wasn't working in a safe, controlled environment. This was the 18th century. Protective gear? Nope. Fume hoods? Forget it. He was constantly inhaling toxic gases and handling dangerous substances with bare hands. He even discovered hydrocyanic acid, one of the deadliest poisons known to humanity, and described its smell as pleasant, like bitter almonds. That's not exactly a good sign when you're working without gloves. It's widely believed that Scheele's early death at the age of 43 was caused by chronic exposure to all the poisonous chemicals he handled. In a tragic twist, the very curiosity that made him brilliant probably killed him. So why didn't Scheele become as famous as Priestley or Lavoisier? Timing and personality. Priestley was a prolific writer and a showman. He loved sharing discoveries widely and quickly. Lavoisier was not only brilliant, but also well-connected in France's scientific and political circles. Scheele, by contrast, was shy, slow to publish, and isolated in a small Swedish town. His treatise on air and fire was published too late to win him credit as the first discoverer of oxygen, even though his experiments proved it years earlier. Still, among chemists, Scheele is remembered with deep respect. They know he was often the first to stumble onto new elements and compounds. His nickname is sometimes the hard luck chemist, a man whose work was brilliant, but whose recognition always came second. And yet his impact is undeniable. Oxygen changed everything. It overturned the phlogiston theory, helped launch modern chemistry, and even paved the way for understanding combustion, respiration, and even life itself. Imagine how different the world would be if we still thought fire released phlogiston instead of understanding oxygen's role. That clarity started in Scheele's little pharmacy lab. One of my favorite things about Scheele's story is how it reminds us that science isn't always about who shouts the loudest or publishes first. Sometimes the quiet figures in the background are the ones doing the heavy lifting. Scheele wasn't a politician like Lavoisier or an intellectual like Priestley. He was just a curious man in a small lab, tinkering and discovering secrets of nature. And in his own quiet way, he changed history. So next time you take a deep breath, light a candle, or even think about the air around you, remember Carl Wilhelm Scheele. He found oxygen first, but the world didn't give him the glory. Still, his fire air became the breath of modern science. That's Carl Wilhelm Scheele, the chemist who discovered oxygen too soon.
George Washington Carver created 300-plus peanut-based products. When you hear the name George Washington Carver, what comes to mind? If you're like most people, you probably think, that's the guy who invented peanut butter. But here's the funny thing. He didn't actually invent peanut butter. That honor goes to several inventors who came before him. What Carver did do, though, was way more fascinating. He took the humble peanut and showed the world just how versatile it could be, making over 300 products out of it. And his work wasn't just about peanuts. It was about changing lives for struggling farmers. Let's back up a bit. Carver was born into slavery in the early 1860s, right around the time the Civil War ended. He never even knew his exact birth date. His early years were rough. His father died before he was born, and his mother disappeared when he was still a baby. He grew up frail and sickly, but incredibly curious. From the start, he loved plants. Locals nicknamed him the Plant Doctor because he'd wander the woods studying flowers, herbs, and trees, always experimenting with how things grew. Fast forward, Carver went on to study agriculture and eventually became a teacher and researcher at Tuskegee Institute in Alabama. Now here's where the peanuts come in. At the time, farmers in the South were struggling. Cotton had worn out the soil, boll weevils were devastating crops, and people were stuck in poverty. Carver saw a way out: crop rotation and diversification. Instead of planting cotton year after year, he suggested planting peanuts, sweet potatoes, and other crops that restored nutrients to the soil. But there was a problem. Farmers said, "Okay, George, we can grow peanuts, but who's going to buy them?" That's when Carver got creative. He thought, if I can show people all the amazing things you can do with peanuts, maybe demand will rise. And so he got to work. What did he make? Oh, just about everything. Carver experimented tirelessly in his lab and ended up creating more than 300 products from peanuts. And we're not just talking peanut butter or roasted snacks. We're talking peanut-based dyes, so you could color fabrics, plastics and rubber substitutes before synthetic plastics were a thing, cosmetics like shaving cream and hand lotion, household items like paper, glue, and even ink, food items ranging from peanut oil to coffee substitutes. And he didn't stop with peanuts. He also developed over 100 products from sweet potatoes, including rubber, glue, and even a type of molasses. To him, the farm was like a treasure chest. Every plant had hidden potential if you knew how to unlock it. One of the coolest parts about Carver is that he wasn't in it for the money. He could have patented some of his creations and made a fortune. But he didn't. His philosophy was that nature's gifts were for everyone, and he wanted farmers, especially poor farmers, to benefit from his ideas. Imagine that. He gave away his recipes and processes freely, believing they were meant to lift people up, not make him rich. Carver became famous in his lifetime. He advised presidents, met with world leaders, and even testified before Congress about the importance of peanuts to the American economy. But despite his fame, he stayed humble. He lived simply, wore the same shabby suits, and spent his days in the lab or teaching his students. Now, here's the kicker. While his peanut inventions were groundbreaking, his real legacy isn't just about the products. It's about empowerment. Carver gave struggling farmers hope. He showed them that they didn't have to depend on a single crop like cotton. They could grow other things, improve their soil, and create new opportunities. In many ways, he was ahead of his time in promoting sustainability, self-reliance, and respect for the environment. He also broke barriers as a Black scientist in an era of intense racism. At a time when opportunities for African Americans were painfully limited, Carver's work earned him respect from people who might otherwise have ignored or dismissed him. He became a symbol of perseverance, creativity, and the power of education. And let's not forget his quirky side. Carver was deeply spiritual and often said his inspiration came from God. He'd walk in the woods early in the morning, praying and meditating, convinced that nature revealed its secrets to those who were patient enough to listen. He once joked that he asked God to explain the universe, but God said, "That's too big for you." So instead, God suggested, "Why don't you work with peanuts?" Today, when you see peanuts in your pantry, whether as oil, flour, or yes, peanut butter, you can thank Carver for making them a household staple. He didn't invent the peanut itself, and he didn't even invent peanut butter, but he unlocked the peanut's potential in ways nobody else imagined. Think about it. One man took a little legume and turned it into paint, plastics, fuel, food, and more. But more importantly, he turned it into an opportunity. And that's why George Washington Carver isn't just the peanut guy. He's the man who helped transform the South, inspired generations, and proved that even the smallest things, like a peanut, can make the biggest difference.
Otto Warburg studied cell respiration and cancer metabolism. When people talk about the mysteries of cancer, they usually think of modern labs, futuristic drugs, or cutting-edge genetic research. But way back in the early 20th century, one man made a discovery about cancer that still blows scientists' minds today. Otto Heinrich Warburg. Warburg was a German physiologist and biochemist born in 1883. If you could picture a scientist stereotype, he fit the bill. Obsessive, brilliant, and not exactly known for his social skills. But here's the kicker. He was also a horse-riding, fencing, athletic kind of guy who believed in discipline and perfection, both in life and in science. His colleagues described him as demanding, stubborn, and laser-focused. Basically, he lived and breathed science, literally. So what did he do? Warburg studied how cells make and use energy. Now, every living thing needs energy, right? At the microscopic level, our cells breathe by using oxygen to break down food and release energy, a process called cellular respiration. Most of your body's energy comes from this oxygen-based system inside little cell structures called mitochondria. Warburg wanted to know exactly how it all worked. Here's where things got interesting. In the 1920s, while studying cancer cells, Warburg noticed something strange. Unlike normal cells, which prefer oxygen to get energy, cancer cells seem to ignore oxygen. Instead, they relied heavily on a less efficient process, fermenting sugar. Even when oxygen was plentiful, cancer cells still chose this backup system. This was a shock. Why would a cell take the harder, less efficient route? It was like a marathon runner choosing to crawl when they had perfectly good legs. But Warburg realized this was no accident. It was a defining feature of cancer. This discovery became known as the Warburg effect. It's the observation that cancer cells prefer fermenting glucose, sugar, rather than using oxygen-based respiration, even when oxygen is available. To this day, it's one of the hallmarks of cancer biology.
Doctors literally use this principle in modern medicine. PET scans, for example, detect tumors because they're guzzling sugar way faster than normal tissues. That idea comes straight from Warburg's work. In 1931, Warburg won the Nobel Prize in Physiology or Medicine for his research on cell respiration. That's a big deal in itself, but his influence didn't stop there. He spent the rest of his career convinced that this shift in cell metabolism was the root cause of cancer. In his mind, damaged respiration, cells losing the ability to use oxygen properly, was the trigger that turned a normal cell into a cancerous one. Now, modern science sees cancer as more complicated than that. Genetics, mutations, environment, lifestyle, all of these play roles. But Warburg wasn't entirely wrong. His work laid the foundation for modern cancer research, and scientists are still exploring how metabolism and energy use contribute to the disease. In fact, there's a resurgence of interest in Warburg's ideas today. Some cancer therapies try to starve cancer cells by targeting their sugar addiction. It's like his theories are making a comeback. But Warburg's story isn't just about science. It's also about the strange twists of history. Remember, he was doing much of this research in Germany during the rise of the Nazi regime. Warburg was part Jewish on his father's side, and under Hitler's racial laws, that should have put him in serious danger. Yet somehow, Warburg survived the Nazi years relatively untouched. Why? There are a few theories. One is that Hitler's regime valued science so much, especially medical and biochemical research, that they tolerated Warburg because of his brilliance. Another story goes that a personal order from Hitler himself protected him, although historians debate this. Whatever the case, Warburg was allowed to keep working when many others in his situation were persecuted or worse. It's one of those uncomfortable, complicated facts of history. Genius sometimes buys protection in dark times. Warburg himself wasn't exactly politically active. He lived for science and avoided everything else. Some say he was arrogant. He believed his work on cancer was the most important scientific problem in the world, and he wasn't shy about saying so. In fact, he once reportedly said that nobody who smokes has the moral right to study cancer. That's how seriously he took the disease. His personality made him a bit of a loner, but it also made him relentless. He worked in his Berlin lab almost until his death in 1970. By then, cancer research had shifted heavily toward genetics and DNA, but Warburg never gave up his belief that metabolism was the key. And here's the thing. Decades later, scientists are realizing he might have been onto something bigger than they gave him credit for. While DNA mutations clearly matter in cancer, the way cancer cells fuel themselves is turning out to be just as critical. Drugs targeting cancer metabolism are now one of the hottest areas of research. Warburg's old ideas suddenly look very modern. So why should you care about Otto Warburg? Well, think about this. Every time doctors detect cancer with a PET scan, every time researchers explore sugar metabolism in tumors, every time new therapies aim to cut off cancer's energy supply, they're standing on Warburg's shoulders. His work continues to shape the way we fight one of humanity's deadliest diseases. But beyond that, Warburg's story is a reminder of how science often works. It's messy. Sometimes a discovery is ignored for decades, only to become important again. Sometimes a person's flaws, arrogance, stubbornness, even questionable decisions are tangled up with their brilliance. And sometimes the simplest observations, like how a cell breathes, can lead to revolutions in medicine. So next time you hear about a breakthrough in cancer treatment, think of Otto Warburg, the stubborn genius who discovered that cancer cells have a sweet tooth for sugar and rewrote the way we see life at the cellular level.
Gregor Reich mistakenly spread the idea of spontaneous bee generation from cows. Imagine someone telling you that if you killed a cow, left its carcass lying around, and waited a while, bees would come flying out of it? Sounds ridiculous, right? Well, for centuries, people believed it. And one of the reasons this bizarre idea spread so widely was thanks to a German scholar named Gregor Reich. Reich wasn't a farmer or beekeeper. He was a monk, mathematician, and philosopher who lived in the late 1400s and early 1500s. He wrote a famous encyclopedia called Margarita Philosophica, which means the philosophical pearl. At the time, this book was like the Google of the Renaissance, a collection of all the knowledge people thought they had about the world. It covered everything from astronomy to grammar to zoology. Students and scholars used it for generations. But here's the catch. Some of the knowledge in it was completely wrong. Case in point, the origin of bees. In Margarita Philosophica, Reich included the long-standing belief in bougonia, the idea that bees could spontaneously generate from the flesh of dead cattle. This wasn't his own theory. It had been floating around since ancient times. Even great minds like Aristotle had believed that certain life forms could just appear out of rotting matter. Maggots from meat, mice from grain, and yes, bees from cows. Reich simply repeated and popularized it, giving it the stamp of authority in his encyclopedia. The idea of bougonia likely came from people observing nature without really understanding it. Think about it. If you saw a dead cow and later noticed swarms of insects buzzing around it, you might assume the insects came from the cow. Today we know they're flies, not bees, and that they lay eggs in the carcass. But back then, without microscopes or germ theory, it looked like life was just magically popping out of death. The story of bougonia was even wrapped in myth and poetry. The Roman poet Virgil wrote about it in his Georgics, describing how if you sacrificed a bull and left its carcass in a closed building, bees would emerge from it. It sounded poetic, symbolic, life springing from death. People loved the imagery, and it stuck. When Reich put this idea into his encyclopedia in 1503, it became even more widespread. His book went through many editions and translations, cementing bougonia in the minds of European scholars. For centuries, students read it as fact. Imagine generations of bright young thinkers being taught that cows could give birth to bees after death. Of course, we now know that's nonsense.
The eventual debunking came much later, thanks to scientists like Francesco Redi in the 1600s. Redi conducted controlled experiments with meat and flies, proving that maggots came from fly eggs, not from the meat itself. His work was one of the first steps towards disproving spontaneous generation. But until then, people clung to Reich's encyclopedia and ideas like Bugonia as scientific truth. So why is this story worth remembering? Because it shows us how wrong science can be just as influential as right science. Reich didn't invent Bugonia, but by repeating it in a respected book, he helped solidify it in the European imagination for centuries. And here's the fun part. Wrong ideas often shape progress as much as correct ones. By eventually proving Bugonia false, scientists sharpened their methods, created better experiments, and got closer to the truth about life. In other words, even mistakes can move science forward. On a human level, there's something charming about it, too. Picture medieval monks seriously discussing whether to sacrifice a cow to make beeves, or farmers trying to coax honey from a dead ox. It's strange, a little gross, but also kind of beautiful, this mix of observation, myth, and imagination. As for Reich, he probably thought he was doing good work. His Margarita Philosophica was ambitious for its time and genuinely useful in spreading knowledge. He couldn't have known that one of the facts he passed along would later become a textbook example of how easily we humans misinterpret nature. So the next time you see a honeybee buzzing around, think of Gregor Reich and his bizarre encyclopedia entry. Thankfully, we now know bees don't crawl out of cow corpses, but his story reminds us of how far science has come and how much of it was built on mistakes we had to unlearn.
Henry Cavendish discovered hydrogen. When you think of great scientists, you might picture someone charismatic, giving lectures, or scribbling equations on a blackboard while students cheer them on. Henry Cavendish was not that. If anything, he was the total opposite. Shy, awkward, almost reclusive. But behind that quiet exterior, Cavendish was a powerhouse of science. He made discoveries so big that they still shape our world today. One of his biggest contributions, the discovery of hydrogen, which he called inflammable air. Cavendish was born in 1731 into one of the wealthiest families in England. His father was a duke, and Cavendish could have lived a cushy, aristocratic life. But he wasn't interested in politics, parties, or even socializing. He was obsessed with experiments. He spent his life surrounded by equipment, notebooks, and an almost obsessive curiosity about how the world worked. The thing about Cavendish is he was strange. He was painfully shy, to the point that he avoided conversation whenever possible. If a servant needed instructions, he'd leave a note instead of speaking. At dinner parties, he sometimes wouldn't show up at all. When women were around, he froze up. He was so uncomfortable that he had a separate staircase built in his home so the female servants wouldn't have to cross paths with him. To most people, he seemed eccentric, even odd. But in the lab, his brain lit up. Now, let's get to the inflammable air. Back in Cavendish's day, scientists were still trying to figure out what air even was. They thought of it as one uniform thing, not a mixture of gases. Cavendish started tinkering with metals and acids.
When he added acid to zinc or iron, he noticed bubbles of gas forming. When he collected the gas and set it on fire, it burned with a faint blue flame. Not only did it burn, it exploded if you weren't careful. Cavendish realized this was something distinct, not just ordinary air. He called it inflammable air because of how easily it burned. Today, we know it as hydrogen. What's even cooler is that Cavendish went further. He combined this new air with oxygen and noticed that it produced water. This was groundbreaking chemistry. For centuries, people thought water was an element, one of the basic building blocks of the universe. Cavendish showed that water was actually a compound made from hydrogen and oxygen. That was revolutionary chemistry. But here's the kicker. Cavendish didn't make a big fuss about it. He wrote up his results in his calm, clinical style, almost like he was jotting down a grocery list. No drama, no eureka moment, just another day in the lab. That's how he rolled. Hydrogen would go on to become one of the most important elements in science and technology. It's in stars. It's in water. It's the fuel for everything from rockets to experimental clean energy systems. And it all started with Cavendish's experiments with inflammable air. But Cavendish wasn't just the hydrogen guy. He was a quiet genius across the board. He measured the density of the Earth with incredible accuracy long before anyone else had the tools to double-check him. He studied electricity, gravity, heat with methods so advanced that other scientists had to catch up decades later. Some people even call him the first real physicist because he blended precise experiments with mathematical reasoning in ways nobody else had. And yet, despite all this, Cavendish stayed in the shadows. He published just enough to get his ideas out, but never chased fame. He wasn't the type to argue, promote, or seek recognition. In fact, after he died in 1810, researchers discovered piles of unpublished notebooks filled with experiments and insights that some of which foreshadowed discoveries made by others years later. It's as if he had stumbled on half the secrets of modern physics, but didn't bother telling anyone. One of my favorite details about Cavendish is that he left his fortune untouched. When he died, he was one of the richest men in England, but he never lived extravagantly. He cared more about his instruments and experiments than anything else. For him, science wasn't about prestige or wealth. It was about understanding nature, plain and simple. So why should we remember Henry Cavendish? Because he's proof that you don't need to be loud or charismatic to change the world. His discovery of hydrogen reshaped chemistry. His studies of gases set the stage for modern physics, and his experiments revealed truths about Earth itself. All of this came from a man who barely spoke to anyone and lived quietly in his lab. Next time you see water, or hear about hydrogen-powered cars, or even look up at the stars, which are fueled by hydrogen fusion, remember Henry Cavendish, the shy, eccentric man who discovered inflammable air, helped unlock the invisible forces shaping the universe, and he did it almost entirely in silence.